Hello, everyone. We're going to be discussing some UFO theory today. I want to bring Ben in. Hey, how you doing, Ben?
Hey, what's going on, everybody?
We're all getting started here. We're going to do a roundtable. It's just going to be us tonight, and maybe Ian's going to join us a little bit later. So, and hopefully Gerald will be here in just a little bit. But real quick, Ben, you got an experiment to put up right now?
Yeah. I've been waiting for this new stereo amp receiver to come, and I tested it out briefly. It works, so we're going to do some over Unity testing, and we're also going to do some testing with the neodymium sphere. I want to mark it like you guys suggested the other night.
Okay.
And what would you suggest I mark it with? Like a line and an arrow?
Well, yeah, just something indicating, you know what I mean?
Which
Some
direction?
Yeah.
Okay. Yeah, I'll mark it with a line and some arrows across in one direction, and then we'll see if we can tell like how fast it's spinning, because that'll give us a better indication.
Right on. Let's do it.
All right.
Go ahead and get set up, Ben. We'll get this thing
Put
going.
on the lab coat. Yeah, let's get it going.
Yeah, put on your lab coat and let's go. Right on, man. Right on. While Ben sets up here. Oh, of course. I tried to say hello and I messed that up. Okay. So, guys, is there anybody out there that's got anything going on today while we're waiting for Ben? What's going on, Lulu? How you doing? So Ben sets up. He's got his lab coat on. Let's check it out. He's got his new stereo receiver now. So he's getting it going, man. He just put in his new coil yesterday, and he's gonna get ready to wind it the next weekend. Yeah, look how little that thing is. So that's awesome, man. Right on. Yeah, I'm doing great. We're just getting everything started here today. Right on. Oh, Ian's here. Hello, Bernie. Everybody saying hi. What's up, guys? Downtown DC. Nice. Right on, man. Yeah, I'm excited, man. We got a lot of stuff going. I kind of want to see Ben's coil, and I'm happy Ian's here to see it so we can see how Ben's working it. So that's going to be really awesome. We've got it all set up. You can see it. I know he's working on it earlier. All right. Get this going, Ben. Ian, you there? I can't hear him. Maybe he's not yet.
Hey, Ian. Yeah, so I'm using my phone for broadcasting the second camera, which I usually use for the tone generator. So I'm loading up the laptop right now for the tone generator. And then that's all I need. Yeah.
Yeah, let's hope he doesn't blow up his amp. Let's all cross our fingers and hope it goes well. So, yeah. Airwaves are hot. Yeah. Just getting a little slow getting it running this morning, or this afternoon, I should say. He's got them all turned on now. Let's see what he's got. Turn it on. Get his laptop program running. He's already got his stereo receiver on. I'm kind of excited to see what this whole coil is going to do, man. Especially if he puts, he's going to say it's going to mark the direction on it. So that should be awesome. Gotcha. Ian's at work right now, so he'll be in a little bit. Right on. Yeah, there you go. Almost got it, Ben. Yeah, here we go. We're looking at it. Yeah, it looks like he's got it running. All right. He's got the circuit going. Yeah, he says thumbs up. Let's go. All right.
All right, everybody, we're ready to go. What do you want to see first?
But mark that magnet and let's see it, man. I want to see that sucker.
All right,
spin.
let's get the neodymium sphere and mark it, and then let me put the resonance to the Schumann resonance. That should give us our maximum effect.
Yeah, go for it. What's up, everybody? Man, this is going to be fun. I like these coils. I want to see what it's going to do. Yeah, we're getting there. Yeah, all three streams are synchronized. So whether you're on, yeah, got a hard hat. Whether you're on Ben's channel, you're on my channel, or you're on BurnEye's channel, we're all in, man. What's up, brother? How's everything going? All right, let's see. Let's hope it doesn't wipe off the mark. So there we go. Marks it. We got an arrow on it. Sweet. See if this thing will stay with the direction or if it goes something different. Do you hear that? Okay, if you can't get down to 7.83 hertz because of the amp, you 2 channels on the output difference. Cool collaboration, absolutely. What's going on, brother? Exotic Propulsion's coming in. We're getting ready for Ben to show us his coil here. He marked the magnet. We're going to see if it changes direction or not. We got Ian coming in a bit. He's working right now, and then he'll be with us when he's done. So, yeah, it's going to be a fun show, and hopefully Gerald's here soon, and we can get this rolling. All right. There we go. It's got it turned on. Putting together a great team. Yeah, we absolutely are. It's starting to come together. Hey, Ben, can you hear us over there? Let me put him on solo so we can get a good look at this. He's got the neodymium sphere in there. Sphere, sorry. It's not moving yet. I'm actually going to do a show on the Gravity Flyer tomorrow. I'll just do a live show tomorrow. But yeah, there's a lot of stuff going on to it. I blow up a lot of circuits on it. It's just kind of driving me nuts right now. You didn't miss anything yet, Mike. We're all getting ready to go. All right, Ben. Oh, moving a little bit. Oh, there we go. So it's starting to rotate, Ben. It's not like looking like it wants to start.
So, a quick update.
Okay, go for it.
So apparently it's not wanting to start the spin, and I think it's not getting enough power. It might be a little bit lower on the power side compared to my other power unit, the other stereo amp receiver. So I'm gonna do some experimenting with the different modes that it has, because it has a couple of different modes that I can use, and see if I can spike the signal a little bit. And then I'll continue to mess around with the frequency, because there is a sweet spot there.
Okay. Well, you get it going. Exotic wanted to pop in real quick, so I'm going to shoot him an email.
Mm. You know what I could do, though? Now that I'm thinking about it, I do have a second channel I can try to hook up to the second channel of the rodent coil. So that should give us a little bit more power.
Yeah, there
Let's
you
do
go.
that.
Yeah, get it in there. What's up, everybody? While we're waiting for Ben, he's changing his coil over. A little bit of technical difficulty. It's okay. He had to do it at the last minute, so that's all good. Yeah, we're all getting going, man. Yeah, we want to see this thing run. What's up, Sean? Nice to see you, brother. Yeah, sorry. Putting up everything I can, man. All right. Let's see. For some reason, Bernie's notification shows up and several minutes later the crypto show. You know, I don't know if somebody else has got like everybody's thing on their list or whatever, but I set mine to mine, so when I type out, it goes to mine. So, yeah, just a little bit of technical difficulties there. Yeah, Ben, they love your hard hat. All right. I don't know if he's doing that, but it kind of looks funny in the background. What is he doing? He's setting it back up. He has the two coils, wires for each coil, and now he's setting them to the secondary one, trying to get more power out of it, get the rotation and the magnet started. Yeah, it might be YouTube. I don't know, man. Now you're over on my right on, brother. As long as we're all watching, it's all good. We're all here to help each other out. Yeah, get him a striped apron. I don't know about that. Oh, you gotta love technical difficulty time. Oh, yeah, that's funny. Huh. His high is funny. All right, looks like he's getting it going again. All right. Let's see. I see the neodymium magnet moving. I don't know if it's rotating yet, but it's definitely wobbling up there. Let's go back to the solo layout. Let's take a look at what he's got going here. Bernie, what's up, brother? Yeah, I don't know about his electrical bill. I don't think it's affecting it much at all, to be honest with you. Yeah, it makes a great hat. That's funny. Yeah, Ben, I think he is muted. Oh. Well, looks like he's putting frequency into it, but I don't know if that program's agreeing with him. They said no go. No go. We got a dud. Huh. Hey, Ben, have you used this receiver yet? No, he's done with it. He's turning it off.
So I did use it briefly, and it does produce over Unity, but I haven't used it for the neodymium sphere yet. I just got it in the mail, like right before we went live.
Gotcha.
I'm going to continue to mess around with the frequencies to see if I can get it to spin. It doesn't look like it's going to spin, though. It might be a little less power than needed for that. But we'll continue working on that.
Hold on real quick, Ben. Before you go back, the other stereo receiver was more powerful. It's putting out more voltage or what?
Yeah, I mean, it appears to be. But to be honest, I can't see where the gain level is when I hit the knob, so it's hard to tell where I am. You know what I mean? There's no display for like 1 through 10 or 1 through 60 like on the insignia. So
gotcha.
It's a little bit cheaper. It works, but it might take a little tinkering to figure out if I can get it to spin.
Gotcha. All right, well, give it one more try and then come back with us and we'll just discuss something else.
Yeah.
You know what I mean?
Definitely.
Just a few minutes and see if it does anything.
Yeah. And I also want to quickly show you guys the over Unity as well, and we'll test how much energy is going in and how much energy is coming out.
Right on. Okay. Yeah, I'm gonna message Gerald and see what's going on because I haven't heard him either. I thought he'd be here by now.
Mm-hmm.
So,
all right, I'll be right back.
Yep. So yeah, let me I'll just message Gerald here. There we go. Sent that off. All right. Okay, well, we're going to watch Ben's lab coat for a little bit, apparently, and see what he's doing. Yeah. The heart makes one expecting something to go boom. I think he's expecting that neodymium magnet to pop out of there and bonk him in the head. That's what I think he's thinking. Huh. What's the latest? Well, I just keep blowing up ZVSs on my gravity flyer. So, hey, if you guys don't mind, while we're waiting for Ben, we'll just talk a little bit. Yeah. So on my gravity flyer project, I isolated parts of my, you can see it behind me, my coil, this side over here, my Tesla coil. So I can pull the oscillation in and pull it out of oscillation quickly. So what it does is I'm getting too much back pressure and it's starting to blow ZVSs quite often. So I'm getting some force that comes back to the disc and it's popping it. But as soon as it does, man, I start getting things that blew out. So I definitely need to put a breaker in there or something to stop that, or just a simple fuse. Be a lot cheaper than blowing all these EVS boards. But I have to have the feedback because I need it to go hot. So the other solution is just run it normal and then put a switch on the wire that comes out of the number 2 coil on the top and just do a switch there. That way I can run it down the coil, okay, on the gravity flyer where it hooks in. I can get it to oscillate perfectly, hit the switch on the wire itself, and it'll bring the heat to the circuit. So I'll turn a cold circuit into a hot circuit real quick so it uses the energy to be able to explode. So I think that's where I'm going on this for the next time, but I have to put that fuse and diode in order to stop this thing from exploding TVS boards everywhere. So it's just the MOSFETs can't handle it. As soon as they get heat, boom, they're done. So let's see, maybe use RFI filter on AC better. Yeah, so I don't use the AC going in as a DC voltage going in. So it's not necessarily an AC thing. When you put the DC in there, it gives you the distance, right, in the field. And I don't get any light up on the end of that wire. When I put in the AC, man, that sucker shoots about 12 inches in the air of absolute sparks. So, yeah, it's just a little bit different on the circuit. Okay. What is this type of engineering called? It's called back of the lab coat. That's what we're looking at. Having fun with you over there, buddy. Let's see. Yeah, the MOSFETs are getting too hot immediately. Like, you can't, they don't like back pressure. And that's why it has to be fused or something, or maybe go into, something else. So, but I think if I just put the wire on the end and use it on the hot side, I might be able to get what I want without blowing it. Even then, it's going to put a little back pressure in it. So it's just fumbling through it, and eventually something's going to work right. So I just can't build up enough pressure to pop it hard enough. So that's kind of the thing. Let's see. For the breakers, it's not so much the breakers I trip in the wall. That's not what I'm talking about. I'm talking more of a inline fuse from the ZVS to the coil. So ZVS to the number 1 coil, it needs a diode and a fuse combo. So a diode to make sure it goes to the out properly, and then a fuse to make sure it doesn't pop back in to my ZVS, because that's the part that's killing me. It immediately goes back and fries it. So, but it's not popping any breakers in the garage or anything. So, right on. Let's see, possibly. Yeah, who knows? Let's see, back and forward pressure only happens when you're out of resonance. Well, that's kind of the whole point. I need to be out of resonance for a few minutes, or like a minute. Well, there it goes. Hold on. You get that thing rolling? Let's see. It's got something going. No, it's just staying there. I think he's going to have to tinker with this thing. It doesn't have enough flow in it. Yeah. What's going on, brother? Your mic's off.
So, is this working?
Yeah, it's working now.
All right, good. Yeah, never know with StreamYard. Sometimes it changes my mic settings between login sessions and whatnot, but that's probably because I'm using a whole bunch of script blockers and various other things, mainly because if my information is going to be given out, I expect something for it. I'm not going to hand it out to all these companies for free, So,
Yeah, well,
anyways,
right on then.
No, so I wanted to talk to you a little bit about your ZBS and some of the problems that are associated with converting it into a Tesla coil driver. Works fine
Go
at
for
lower
it.
frequencies. Okay, the two resistors that are on the ZBS are there to provide gate pull-up voltage, and the speed at which they are pulled up is based on the input voltage to that circuit and the resistance. That has to do with the gate capacitance, and so they're designed for operational frequencies less than 100 kilohertz. When you start to operate them at much higher frequencies, they can't pull the gates up fast enough, which causes the MOSFETs, instead of turning on all the way and giving you those super low on resistance properties you're looking for, it causes them to turn on slowly, so they act more like transistors and they operate in the linear range. Now that's a problem. So the first mod to do is to actually double up or triple up on those resistors. I believe that the diodes on the board that you have can handle the amount of current if you divided your resistance by 3, just so you could pull up a little bit faster. That would get you into the 300 kilohertz range. You may need even less. I use only 5 ohms of resistance on my pull-up for my high-frequency 400 kilohertz CVS circuits. That is way lower than the 50 ohms that comes on those boards. So,
well, it's not necessarily getting it oscillating in the beginning, right? So I get it oscillating at 280 kilohertz, no problem. Okay. And it's perfect oscillation. It doesn't blow any boards. It's when I start pushing back on it, you know what I mean? To get a hot voltage out of it.
So
I
when
want
you
to
start to load your secondary?
Yeah, when I want to put the power back into the primary and hold it for a second and then burst it out, that's when I'm having trouble.
Okay, well, that makes sense. And again, here's why. It's for the exact same reason that I talked about. Your MOSFETs may be switching, but they're not carrying a huge amount of current when the secondary isn't under load. When you put it under load, it magnetically feeds back to the primary, which puts your primary driver under load, and your partially conducting MOSFETs are losing a huge amount of energy due to the fact that they're not completely turned on. So fix your resistor problems, start with that, and you'll find that it probably fixes a lot of your problems right off the bat. And then you can deal with your connections on capacitance. Obviously, you want really short wires. You don't want these long leads. You don't want them wrapped around each other or coiled up. That causes extra leakage inductance and can throw off the circuit. You'll end up with just a bunch of additional heat in that case if you have all this leakage inductance that won't be generating any extra output. So it'll feel like your primary is really hot, but for some reason the secondary just isn't oscillating. That's because the frequency of the circuit is supposed to be coupled to the secondary. And if you have like 2-foot wires going off your primary to your ZVS, that's a huge amount of extra wire that's going to drop the frequency, and it will no longer be in resonance with the secondary.
Right. So the wires are about 5 inches.
Very good.
So they're very short. So like I said, it oscillates perfectly, and that's with the capacitance of the gravity flyer. So, or the load, however you want to say it. So basically, it resonates at about 710 on the secondary, and then when you hook up the gravity flyer, it resonates at 310. When it goes into perfect oscillation, it starts resonating down at about 280, and it sits there perfect. And I can boost it up to about 80 volts on the DC side without a problem. Okay. And it does not blow. So it's a monster, right? The thing is, I need the hot side. That's why I said it goes in cold because the wire's down the throat of it, right? So it's adding like it's like a number 2 coil is expanded is what it's doing. It feels like, right? When you put the thing down the hole, it's like I added a bunch of wire to it. Is what it's acting like, and it comes out ice cold on my center plate. Now, in order to use that energy, I need to heat it quickly. So I need to pop it with heat. So I can either, do the back pressure, or I was thinking I could just take the wire that's coming out, since it goes nowhere right now, of the set number 2 coil, and I could put a switch on it and just switch it and then automatically hit it for 1 second like a button and then pop it with heat. and then just throw heat into the circuit so I can use the energy real quick and create an explosion.
Okay, so that's a possibility. I have a video up on YouTube on my Exotic Propulsion channel about a super simple solid-state Tesla coil. And that thing can crank the heat at a low operational battery voltage of like 8.4 volts input. And so you can physically put your hand. What I did is I hooked up the output of this coil. It's like a 30 gauge secondary through a 40 watt light bulb. And then the other side of that 40 watt light bulb was connected to a hard drive platter that I had up on an insulating post. It's like a foam cup or something. And I could place my hand really close to the platter, and within about half an inch or so, you could really feel the heat that was being generated in the air just from that capacitive coupling. And at that point, what happens is it goes from drawing like 2.5 amps up to drawing almost 7 or 8 amps. And it delivers that power pretty effectively and still maintains to keep the circuit cool enough. And the way that particular circuit works, it doesn't have a resonating parallel capacitor, so it can shift frequency really, really quickly, and it can do it very effectively because it's purely based on current transformer feedback from the secondary. So imagine it sort of operating like a Slayer where the secondary base feedback sets the frequency, but imagine that it operates more like a ZVS because instead of going into, directly connecting to the base of a transistor, in this case, it goes into a transformer that push-pull operates the two MOSFET gates and powers them directly. And then so it also has a set of 4 diodes that clamp off the voltage that can be fed to the MOSFET gates. So there's no need for Zeners or lower power things. You can use nice fast Scotties. And that circuit you can instantly just, as soon as you couple, you can feel the heat immediately in the air and it just starts pouring off and you can feel that on the surface of your hand. So in terms of like bumping power into it, I designed that driver to operate my gravity flyer and get the heat in there. And you can immediately hear too, the whole thing go into resonance. It starts to make a really interesting hissing sound, and then you start to get coronal discharge because of the electric field volts per meter suddenly being increased due to the high frequency injection. So I'll have to talk to you about that circuit, or you could even put that video up if you wanted to. I guess I could send you a link from my channel. I also
send it in the private, and I'll pull it up. So because I'm working on the ZVS. I got this thing, man. You put it on the gravity flyer, put it outside. I'm going 8 to 10 feet on each side. This thing is lighting light bulbs up everywhere, right? So I know there's plenty of power in this thing. Okay, it's getting that conversion, and there's so much static in the air based on the way I changed it. I changed the leads going on the plates, everything. So it's so much better. Like I don't have to wait for static to build up. I could build it up right away because as soon as that Tesla field goes on, it's already set the field. So now I can fill it. I don't have to wait. The only thing I'm waiting for is my magnets to get into resonance with my plate because they start sending off that ring. And if that doesn't come in clear, you have problems. So I'm just waiting for that to come in. Once that comes in, man, boom, I can hit it. So you got that? Let me look in the.
Yeah, I'm trying to find it on my channel here, and my computer is basically just dying from attempting to do the stream and allowing me to search. So,
gotcha.
Try one more time.
Let me look it up. So Ben, no go
here. Yeah, with the neodymium sphere, it's not powerful enough. We'll have to figure something else out. I'll probably get a new one for that. But in the meantime, while you guys are chatting, I'm gonna do over Unity test, and just so you guys know, because I won't have my mic on, I'll be doing 25 hertz or a lower frequency range, and then showing you the voltage and amperage input output, and then compare that to 800 hertz on square waveform.
Okay.
I don't have the reference circuit hooked up right now just because the fan, one of the fan wires disconnected. I was hoping at some point, maybe on stream, maybe I could just solder it together real quick. It's just one little wire.
Gotcha. Exotic, this is your channel.
There it is. Okay.
Nice.
It's the thing with the light bulb in the center. Thanks. I'm still literally waiting for my page to load, so I'm just going to go ahead and close this. And see if I can pull it up.
It's okay.
It's like that. Yeah.
Tell me which one.
It's that one with the red cup on the left and the plate on the right, or what? The red
I don't
coil
think
on
I've
the
seen
left
that
and
one
the
yet.
plate on the right, and the light bulb in the center. It's
Okay. Second row down, second one over.
Yep.
Okay.
Just a quick update.
This on the other screen so I can see it.
Reviflyer Tesla driver board again, so that we could get the maximum power with the absolute minimum number of components. And I would say this is it. These are snubber capacitors, which aren't required but recommended, and this is just an LED indicator. So this whole circuit here, the entire driver, is just 2 MOSFETs, 4 diodes, and a center tap inductor, which you could also use 2 separate inductors, and it works perfectly fine. I've got one already set up over here and plugged into the power supply. And to show you what we have going on here, the output wire from the secondary coil is passing through this 40-watt incandescent filament lamp and then terminating on this 3.5-inch hard disk platter just being used as a top load. So what this is going to show us is that under various loading conditions, this thing will crank the power. I'm now going to bring it up to 8.4 volts. It will operate very nicely up to 16 volts. But if you just wanted to use a 2-cell LiPo battery, it works great off that. So here we are, 8.3, 8.4 volts, drawing about 1.4 amps idle. But if I give it a bit of a capacitive loading, check this out. Boom, that is full illumination past 40 watts. So we are passing more than 40 watts through this incandescent 40-watt bulb now. And you can see we're drawing quite a bit of power now, 8.2 volts at 6.7 amps. And so the rest of that energy is actually going into...
Okay, so hold on.
Okay.
As soon as you did that, you just added, what did you add there? Capacitance? Is that what you said?
I just brought my hand close and I dropped the frequency of the circuit slightly. That put the tuning point of the primary coil replacement into ideal resonance. So I'll just add one little piece of information that's kind of important to understand about this circuit. Because it is so simple, it uses a little CT, like I mentioned, that feeds the MOSFET gates. Well, when you add capacitance on the output, it gives more energy to the gates, actually providing that energy. So instead of having resistors like the ZVS, the more it needs, the more it gets. It automatically feeds itself back. So when I put my hand close to it, I increased the loading energy, dropped the frequency, and the power draw went into phased resonance. Now with my hand and her body being part of that circuit, just capacitively coupled.
Now,
so the next part is what I was talking about, the heat too.
Let me just tell you something right now. I've been talking to TT online. He's on the Gravity Flyer group on the Facebook, and we're talking about building a pure capacitor without the center plate being metal. So it would be a capacitor between the top and bottom plate. Center plate is clear acrylic, and then we get the capacitance. So the thing is, that piezo buzzer does that same thing. It'll add capacitance to it as a capacitor when you set it up without the metal center plate. So
yeah,
just
you can try it.
Yeah, well, you got to try everything. So I have 3 of these things. You know what I mean? So
yep,
we're going to rip one apart and try it because he's telling me he's dead set that it's going to do it. He's dead set that center plate is plastic. So I'm just going to try it and we're going to find out. You know what I mean?
That'll
He's
be
pretty
interesting.
good.
Yeah,
Hey,
that'll be really interesting.
He's gotten lifters to lift with his Tesla coil, man. So he's got something in there. All right. Let's get back to the
dielectric field above and around this top load disc. And if I bring my fingers a little too close, no arcing, I can feel the heat from that dielectric field. So a lot of the energy is being radiated out, but it's quite surprising just how much current is actually being passed out of that secondary coil. And it looks like the super simplified driver with the minimum components, it can work pretty darn well being stripped down like this. So it looks like we might have a winner. I would say that about sums it up. I'll be pumping out those schematics once I verify that the driver board is not having any problems with various super cheap MOSFETs.
So I can send you that schematic too. Just email that to you, and it's a pretty easy assembly, honestly.
Yeah, I appreciate it. You know what? I just realized how to get it.
Yeah,
Yeah, it's that
nice.
simple.
So what's the
All I need to do is add the capacitance, which all it was is the piezo buzzer's not big enough.
that could
That's
be.
it.
I tried arrays of larger piezo buzzers, use huge transducer discs, try to get the volume up. It's like, you start.
I'm
hitting
just gonna
limits.
drop. I'm gonna take out the 1 and drop in 3, and hit it.
Yeah, I've done 3 as well.
Because not on top of each other.
No.
I'm gonna just
Side by
do it.
side.
I'm
Side
gonna
by side,
triangle them.
triangle. Exactly.
Yeah. Well, because here's the thing. I'm getting all the energy I want. I'm just not getting that pop. And if you're right there, then all I have to do is hit the pop. Is just get that heat to pull in just a little more. Yeah.
Pretty
There you go.
straightforward. That just pops right on top.
Yeah, see, I got that ultrasound set, man. Perfect. I hear the little clicks in it. I don't know if you saw the video, but as soon as you turn it, I can hear the click, and then turn it the other way and hear the click. I know exactly where this thing's at. You know what I mean?
Yeah.
Where the hot spot is, where where it's going to hit. When I push that button, that plate in the center starts to react. It starts popping. Well, all I got to do now is pop it on the 2 plates. You know what I mean? And get that resistance to change, and it'll send that circuit hot. So,
yeah, that should work. That should work. I mean, in the one case where I was just looking at the current, sorry, just watching the current draw, I turn on the electrostatic field. All of a sudden, the air is now ionized, and so it's in a plasmatic state. Then I watch it fall into resonance again and start drawing a bunch of current as it gets delivered into the electric field. And that you can start with just the DC high voltage. You generate the electrostatic field, you generate the ions, and then all of a sudden, the circuit begins to act much differently because the effective distance between the plates, it's decreased due to the fact that you have all these free charges conveying the energy much more quickly than just an open vacuum where epsilon alone would do.
So did yours start to shake a little bit more?
Oh, yeah.
Yeah?
My plates are extraordinarily balanced, so it barely vibrates at all. But it was enough for it to just start scooting across the bench.
Okay. Mine goes up and to the left. The whole thing starts like this. Okay.
I haven't had mine lift yet at all, and I haven't really spent too much time messing around with it. I built it. I tried a few variations. I thought, I already have another solid state version design that is quite different than anything else that so far we've seen from the Grubber Flyer community, and I haven't disclosed all the details of it, but I've done plenty of descriptions of basically how it's assembled, and it uses a bifilar pulse coil in the center, and that coil is made out of carbon, which kind of acts like a plasma on the surface when you pump it with current. And the reason for why is carbon nanotubes transfer electrons at a speed of 42 billion times faster than they actually flow through copper. So you end up with this relativistic effect that's added to the electric field, and that generates torsion. And we want that torsion to actually exert forces on the charged plates on the top and bottom. So it has a positive plate on top and a negative plate on bottom, just like the Grubby Flyer. The difference is instead of just having 1 plate on top, there are 2, and the same thing on the bottom. They're spaced out just a little bit from each other by about maybe 1/8 of an inch. And lasers come in from the side in order to push charged particles that are generated or pulled from the vacuum out of that system. And so the way that it operates is quite a bit different in terms of the dynamics for a pulse field. But what it's doing, in my opinion, is the exact same thing as once that Grubber Flyer gets in the air. And I think they're effectively doing the exact same thing to the local space-time, and I think that they operate by the same principles. So I haven't got that one flying. I'm still working on the specialized material in order to get it to work. I use a metamaterial mixture, which is a combination of hydrogel, graphene, bismuth, and a proprietary perovskite mixture in order to make it photoreactive within the laser wavelength that I'm trying to pump for. And
going all high tech on us now.
Well, that's in order to get this high electron drift velocity, right? The hydrogel is saturated with graphene platelets. The edges of the platelets are super sharp, which means that if the electrons experience this magnetic torque that makes them twist, and these platelets are aligned flat, the electrons are all going to be trying to push. They'll be pushed to one side of the platelet, and when they reach a high enough potential through the hydrogel, they'll leap off, and that gives them an incredibly high velocity because it's like releasing a spring or releasing, an arrow from your bow, and it just pops back. So you built up the tension electromagnetically by using the torsion field, and now you're just getting a sudden release. Well, that release then has to interact with the vacuum at very high velocities. So now we get relativistic effects inside of a semi-solid material, which is kind of nice because how else are you supposed to achieve ultra high velocities in a really short distance? And that's one of the ways that, I'm suggesting that's why we use graphene platelets, because it's a really simple, cheap, easy solution. I mean, I just make them in a sonicator. It costs me almost nothing. And so for like $5 of graphene platelets, I can make my material coatings for all 4 discs.
Gotcha. Yeah, I'd stick to the old school stuff, man. I push out so much static electricity I can fill the room within less than a minute. So it's all in the you have to set up your top and bottom disc as a little capacitor when it goes from the high voltage to the plate itself. And you have to put something in there that's going to create the static. So like I always test it with a dryer sheet, and a dryer sheet will do it real fast because it changes the ability for it to throw out everything. It immediately takes the very, very low amps that I'm putting into it with a very high voltage, and it automatically converts it quickly. So you're getting the field filled up quick. So I don't know, man. I hope your high-tech way works. It'd be cool to see.
I hate moving parts. I'm looking for a better solution and trying to maximize the field stresses that are present there. So it is a much more difficult approach. There's no doubt about it. But I figure it this way. We already have 20 people or more in just, the Graviflyer communities that we're part of that we know have working, testable. And by working, I don't mean they actually fly, but I mean the motors run the high voltage supplies and test the coils. Everything is functional, basically, so they can do experimentation, right? We already had plenty of people working on the mechanical version. I want to do something different, so instead of just repeating what everybody else is slowly coming to the conclusions of in terms of what does and does not work mechanically, I'm just going to try to avoid the entire thing altogether. And so, yeah, mine will take a lot longer to build than the mechanical version, but also it's going to give me a lot more control than the mechanical version because no moving parts, no vibrations, no false measurements, all direct control.
Got it. Yeah, I was thinking, to be honest with you, just to put a shell on the outside, because this thing is absolutely awful at retaining the field to get it thick enough to hold everything in that you want. You know what I mean? Mm-hmm. Because as soon as you start overdoing it, it starts spilling out. So there's not enough rotation on the outside for the Tesla coil because it's static in the center on that plate. It needs rotation for the entire craft in order to get the field thick enough to hold it in. And when I put the Tesla coil on the discs themselves, then the field gets thick enough to hold things in and push things out at no problem with no loss. So you really need a rotating field or a rotating disc or a rotating outside, enclosure in order to get this thing to hold it properly. So you're going to have you're going to have some form to hold it in unless your actual frame holds it in no matter what when you build it.
I mean, as far as the enclosure goes, I was already advised that this can be completely enclosed and be fully operational. The field will extend beyond the enclosure and still operate on the outside. And so there are a couple of things that I'm looking for characteristically coming out of the system. One of them is an extremely high frequency optical output that will be significantly shorter in wavelength than the IR pump for the diodes. And so that's an easy enough thing to look for because it'll be visibly pink. The second thing that I'm checking for in the solid state system is part of its operation does involve the production of antimatter through separation of virtual particle pairs in the vacuum. So in order to detect the signature of antimatter, I do have an extremely sensitive Geiger counter that I've got a large pancake probe, window probe on, and if I hit there, I'll know it immediately because I'll get a burst of clicks. And so that will tell me that I basically hit the Schwinger limit in terms of field energy required to separate virtual particle pairs. And if I can get there, then that's this thing is much different than Grab a Flyer in terms of its lifting capacity. Theoretically, it should be capable of lifting maybe 10 to 15 pounds in addition to its own weight, which kind of puts it in a different class of devices.
Yep. I think he built with a solid plate in the center, he built a field generator and it happens to lift.
Right.
I in no way think he built it to be a craft that goes airborne all the time. That it's supposed to do that. I think he got lucky that it lifted, to be honest with you. But it's definitely a field generator if you know how to tweak it. So I don't know. There's a whole different way to build one of these things. It's so much easier. So much easier. I have a solid state version myself, and it just works completely different.
Exactly. But you're playing around with it at least, and that's really important that we kind of diverge, because you're going to learn things from those types of experiments that you won't ever see on the motional version, and then you can apply what you've learned there and get a better comprehension or understanding of what the field geometry is, what kind of potentials are needed to saturate it, what kind of magnetic fluxes are actually required to get the penetration depth or eddy currents if they're involved in this scheme. So, there's a lot of questions that it helps answer too, and it gives you a little more control because it's not shaking around and jittering. So.
Well, I tried to tell everybody else that you got to throw away those neodymium magnets. They're killing your gravity flyer because all they're doing is producing heat in the center plate, and if you got a cold plate, you're using the energy before you can use it. If that makes sense, you're already killing it before it builds up. It's a complete waste of time, and I don't care how many gouts it's got. It's worthless, completely worthless. You have a short field. It's about that small. That's your max level. That's the best the neodymium can do. Then it gets so much weaker as it goes out, where the other field will actually convert and touch the other plate. So,
that has to do with the velocity of the electron valences inside the neodymium versus the iron boron. Your ceramic magnets have a totally different radius and a different electron velocity that puts them at a slower speed. And so the field effectively reaches out a lot farther because the wavelength for their oscillation going around one rotation is much longer. And so that longer wavelength directly equates to a change in the field permeability of the localized space. Neodymiums are great because they concentrate the fields, right? So everybody thinks they're the greatest thing in the world because they're so strong near the surface. But of course, a neodymium is not that. It's not that it's that much stronger than an iron boron or some other kind of magnet. It's that its field is so focused inwards that you're really sacrificing range. And sometimes you want range, and you want the ability to actually get those fields penetrating instead of having to perfectly space it, which kind of kills your ability for electrostatic tuning, right? So I agree about the magnets idea. I still think that neodymiums can work. It's not necessarily a complete deal killer. When Charlie got his gravity flyer directly from Alexei, those were busted up neodymium magnets.
They're Linko. They're not neodymium.
Well, he says
there's about 1,000 gout difference.
He says that they were, but I looked at them and I looked at the color, and I asked Charlie to take really up close pictures to see if they actually were, and I've busted plenty of neodymiums and they look identical. And I've seen Alnico magnets and they look significantly different. The color is different, the coating is different, but these were classic, nickel copper plated, so they look just like neos and they use the same modern neo process. So either he bought something that he thought was different, or what he said he sent Charlie is different than what he actually sent Charlie.
Yeah, well, I could tell you based on the results of the lab work that the neodymiums are garbage. They put out a garbage ring. They don't have enough, they don't produce a big enough field at a good strength. You know what I mean? It's a massive drop off, and you're not getting enough speed on this to get the right strength anyway on our neodymium. So the difference is we're running about 700 RPM on the bottom disc because they're fan motors, where I'm not running DC motors like everybody else is. I'm not trying to overpower it. So that field has to be created with the ceramic. When you use the neodymiums, you have to get it up around at least 4,000 to 7,800 RPM to get at least a 1-inch field coming off of this thing, where you can actually feel the eddy current. Otherwise, it's garbage. So it will put in heat, and then it'll warp the living daylights out of your center plate if you try to put magnets in both ways. Complete junk. That idea was the worst thing you ever came up with. And everybody keeps repeating it to me, and I showed how it works, and it's garbage. Complete garbage. So,
Oh man.
yeah, I don't know, man. They just should have used the right stuff from the beginning. I took off all the shells, and I just went with the ceramic because it's so much better of a field. I get a beautiful ring out of it. I get a Tesla coil ring out of it because all the wires are weak. They're low shielding on all of these wires. So you get one ring somewhere, you get a ring everywhere else. You line them up and you amplify them. So it gives you the proper stuff to work with. This other DNM garbage it was a killer right off the bat. Immediately used up all your Tesla coil energy. It was worthless. So at least that's my opinion.
Yeah, there's a lot to consider there. I mean, I'm just thinking about the hundreds and hundreds and hundreds of hours that we put into testing these things, and
like I told you, it's a field generator. I'm not lying to you. I can produce a beautiful field bubble out of it. Okay, and you get that Tesla coil spinning, it's a whole different ball game. Now, my solid state version has a Tesla coil right in the center. Okay, and it has the primary on the outside. But then the other two, coils on it are much different. So it's just a better way to go because then it allows me to do everything I want. Okay. And then I get the vortexing. You know what I mean? I get that thing to build up, and it has a shell on it. So it's not anything close to what I'm going to show anybody until it has its final result. You know what I mean? But it's a beautiful machine compared to the Gravity Flyer, you know what I mean, that we normally deal with.
Oh, yeah. I'm going to see if I can pop this up real quick, speaking of rotating fields. Okay, don't know where my present window went. Try that again. Okay. All right, I guess I can just share. I'll try this. This is probably gonna have problems playing, but we'll see. So this is the phase controller for the 6-phase bobbin spacecraft coil system. And when you get the compass synchronized up with the rotation, you get this really good coupling. So that thing will be just cranking around and start shaking back and forth. But this is just to kind of show that you have a rotating field and that you can generate a very strong rotating magnetic flux there in the axial direction.
The neodymium on the right, or excuse me, the lights on the right is following the field.
Right. The lights on the right are telling you each of the coils that are firing. It just tells you when each of them is connected to which MOSFET here. So it shows you what the coils are doing effectively. Okay. And it's just an indicator. It's a way of, if you don't have a compass and you don't have the detectors on, you can still see what's going on. But this thing, that's at pretty low frequencies. And so I'm going to go ahead and stop sharing on that screen and then go back to see if I can do this one. Let's see. Yeah, it looks like I can do that. So there, I can put this, and hopefully we can see the window. So down here at the bottom, this is the basic layout of the bobbin spacecraft here. And inside of it, there are 3 main components that we need to look at. We have this solenoid coil. This is just like, your normal electromagnetic solenoid. Produces a magnetic north on the top and a magnetic south on the bottom, and a rotating electric field that is following axially along. Now, second part is we have these coils, which are orthogonal to this big coil, and they produce a magnetic field that follows the core, part D here, in a circular fashion as they're fired sequentially, just like we watched in that video. So what they effectively do is when we combine this type of field with the magnetic north on top and south on the bottom with this type of field produced by the bobbins with an electric pole on the top and an opposite electric pole on the bottom. So this could be positive on the top and negative on the bottom, or we can switch those places. There's an interaction between the coil on the inside here and this orthogonal coil on the outside, because they both are trying to magnetize the local space. They're trying to send out that same magnetic field that's transmitted by any magnet or any coil when you have a current flowing or when you have electrons cycling around in a loop. And the problem is that space-time can only hold one of those two fields in a particular axis. So when you take the two and you cross the fields, space-time has to contain all the energy, but the two coils can't actually interact with each other and cancel out in any kind of destructive or constructive waves. So the only way that it can store it is gravitationally. And just to sort of build this better, I redesigned this from the old core that I was using, which is hanging around here somewhere. Yeah, so this was the old core that I was using, and this is steel that was glued all tightly together so that these plate laminations can't actually vibrate against each other. And when you get this thing going, you start out at a lower frequency, you can really hear it start to ring. And when you get the magnetic field in the center just right, it gets really loud, and you can take this one up to about maybe 70 to 100 kilohertz. But going back to that other core, in the on the inside, there's this second coil. This is the one that we see in the internal solenoid. And what it's going to do is, as the field kind of travels around the core in a clockwise or counterclockwise direction, depending on which way I want to run it, the dipole moments are being tilted to the side to try to follow that field. But meanwhile, each coil that shuts off, there's this other coil that's trying to tilt those dipole moments back upright. And so they start to get flipping around like this. And if we can get them flipping at just the right rate, we can get them to flip in a precessional path. And we can store that energy up locally so that the total field is much larger than the superficial field. And so when the whole thing is wired up on the bench like this, what it looks like, I've got to deal with all these wires, tie it all together, put this all on basically a piece of board or whatever and hang it from a scale. And then I also want to see if it has a torsion or a twist. Other interesting stuff that's relevant to you, and I can go into more of the technology and how that system is supposed to work, but Adam is also building a version of it. And he built something kind of curious. So here he's got these individual coils. He stacked them up first layer like this. This is one of the two phases. And then he stacks a second layer that's exactly in between. And he shifts the phase of that layer 90 degrees. So he gets a rotating magnetic field that travels around whatever he puts this coil on. In this case, he's testing a cast iron pan to look for the penetration depth at a certain amount of power at a certain frequency. And so he's feeding it with a function generator through this amplifier. And then on the back side of the pan, this simple coil is picking up the magnetic field. So whether it actually gets through the pan or not shows up on the oscilloscope. And this tells us exactly what frequency we get in terms of the eddy currents traveling through the pan in order to penetrate through it. And we can stick any material in front of that little array, like an aluminum disc from the center plate of the Grevy flyer or something else, and see what the difference is in speed and how long it takes for the eddy currents to basically become neutralized and the magnetic field to pass through. So it's just another way of testing it, trying to get more data that is otherwise pretty hard to detect on the Grevy flyer. And it's a very practical approach. So I can stop sharing that now.
What's that? He created a motor out of it. What's that motor is called? I forgot right off the top of my head.
It looks like an axial flux motor, if that's
there you go.
The winding design. Yeah.
And then when you cross it, you can run the eddy current into an aluminum disc and get it to spin.
Right. You could do that.
Okay.
Yeah, I actually asked him to take a video of doing particularly that because I figured that would be a good demonstration of showing the rotating field. And
well, yeah, because it shows the eddy current better.
Right. Exactly. Yeah. Just seeing the rotation is nice.
And then you can hook it up in order to see how much voltage and current you're getting out of the eddy current on the plate. So there's a guy online that does it. I saw a bunch of his videos, but he's pulling it as a generator.
Yeah, one of the other things that he played around with that I thought was a really good idea or a good approach is he put a dielectric insulator between the coil set and the back of the pan. And he charged the two to a high electrostatic differential potential to see if removing charge from the iron would cause the penetration depth to change at all. And so that appeared to have no particular effect on it at all. But there could have been issues with the setup too, so the arrangement wasn't exactly ideal. Anyways, it's something else that we still wanted to look into: is can high voltage actually change the material's resonance and various things like that?
Take a rod and when you put it on your plate, build it just like you would a DC motor with the brushes, and then pull your electricity from there. It should be able to tell you a lot. You know what I mean? So every time it goes around the brush tells you exactly what it's doing. You know what I mean? And then, yeah, I'm just saying. It would be way easier. And the feel, you know what I mean? Whatever that disc is putting off, you should be able to pick it up on your oscilloscope pretty easy, shouldn't you?
Well, yeah,
on the vibration that's created.
Necessarily tell us the penetration through the thickness. That can tell us.
That'll tell you the penetration. I agree with that.
Right. So that's why we were testing it in the way that we were, is so that we can tell actually, what speed that field needs to move at and at what strength it needs to be, which basically allows us to figure it out with the rotating magnet assembly on the Gravity Flyer, or with the solid state system, like we're working on with this rotating magnetic field system, and the bobbin electromagnetic spacecraft patent stuff. So it's just more to inform us about how the cores are going to react and whether or not we can actually reach the field intensity we require in order to get an interaction strong enough for observable effects. But that's it.
Yeah.
That's pretty much all I had to present today. So I just dropped on to share a few tidbits, and hopefully
I appreciate you coming by. But I want to check out that Tesla coil circuit for sure. So if you got it, send it. If not, I'll just look at what you did, and I'll be able to put it together. So
yeah, it's really straightforward. Charlie C also has posted up, I think, a video showing that circuit too, because I sent it to him. And so you could probably just go check out his channel if you didn't want to wait. But he's got one up there somewhere of the whole thing. So, all right.
Yeah, Charlie's been putting up some pretty good stuff on there. I've seen his Tesla coil he just did. I don't know if you saw it. It's amazing. It's just it's awesome.
2 years of Gravity Flyer research he's been playing around. So
yeah. Well, he put a water pump on it. I mean,
the whole water cooled system. Yeah. I know. Way overkill for me. Like, if I'm gonna have a Tesla coil that's operating, I can draw. If I'm drawing like over 100 watts or whatnot, I still want my FETs to run cool, or my IGBTs to run cool. If I need a water pump, if I feel that that's actually something that I require, then I'm running that circuit so ineffectively that I'm going to redesign it until it doesn't generate the heat anymore.
Well, look, check this out real quick.
Yeah, I've seen it. I mean, I've seen his video.
This is the wire that I use on my ZVS. That's this one going in. So cheap little 99-cent store wire. And I am pushing 12 inches on an AC field on my Tesla coil because it's so in tune. I get absolutely zero back pressure with this little wire. Normally you burn all these things up. Yeah, not with the way I'm doing it.
The nice part is you're operating at a really high voltage too. So that much higher voltage in, like, you're seeing 8 or 10 amps draw on my meters from that kind of stuff, because I'm operating down at battery voltage. I figure if I'm going to design something, I want everything to be capable of running straight off a battery pack and not screwing around with a variac or anything else like that. That's good for learning about it. Yeah, it's very bad for field deployment. You don't want to have to drag all that stuff out there, right? So if you
you will need it in some versions. I can tell you that.
Hopefully not.
I got my little RC packs. You know what I mean? 12 volts, can throw it up to 24 if I want, and they're very small. The only problem is when you start messing with frequencies, man, things don't work right. So that's the only thing to overcome on that. You know what I mean? To get it completely to a controller basis, and it's kind of a mess.
Oh yeah.
So yeah, but I like his water cooled system just because it looks cool.
Oh, I agree. I agree. He did he outdid himself with it. He didn't solve the engineering problem of the heat generation. He just patched it up with a water cooling system. So
yeah, I've never seen anybody take a Tesla coil, put water in it.
Really? You should.
It was the first time I've seen it, so I just thought it was like the most amazing thing. Not because of the functionality, just because of a cool factor.
Oh man! So we used to throw these huge Teslathons, and we get people like Steve Ward and Terry Blake and Greg Lay out there and stuff, and so we'd have these massive solid state coils, and they had all of them were water cooled systems. I mean, we were pumping ridiculous amounts of power, about maybe 50 to 100 kilowatts through these IGBTs. And
Oh, nice.
so obviously, they're water cooled.
Might have to go there and check that out. That seems
We
pretty
don't
awesome.
do it anymore. I mean, this was years ago, back when before the whole pandemic thing and everything else. But we used to throw these huge testathons and all that. All that is gone now, but we've still got the equipment. And Steve's still been playing around with that stuff. So I mentioned Steve Ward because him and, what was the other guy's name? Jimmy, I think it was. Invented the first DRS STC circuits that really popularized solid-state Tesla coils and musical Tesla coils. So they're the guys that actually came up with it.
Yeah, right on. That's so cool.
All right, well, I'm going to jump out, and I'll leave it to you guys.
Right on, man. Thank you very much for stopping by. I really do appreciate it.
Thanks. Good luck with your circuits.
Thank you. All right, Ben, where we at? Ian, how you doing, brother?
I'm good, thanks. Sorry for the delay. Work beckoned. Yeah.
I think I figured out your winding on your coil, right? The one that you were showing Gerald last time. Okay. Let me pop it up real quick. Let me get my screens to work here for me. Just want to see what you say about it. Give me 1 second. Almost got it. And here we go. Is that anything close to where you're at? So the green represents one winding, the yellow the other. They're 180 degrees out from each other, so it's flipped over. You have a square and a triangle.
Okay. It's more than that. It's there's triangle, square, pentagon, hexagon, octagon.
Really?
And then the reverse, going back into a triangle to finish off on the top. So it was kind of widening out and then closing in again at the top.
Oh,
so
okay.
That's what I was
just trying to figure it out.
Yeah, I mean, it behaved. I was running some tests on that and the new one I made today, and that one behaves a lot better than the ornament I just made yesterday.
The ornament,
but you see, I don't know. It's like I thought the one I made yesterday on the toroid. This one.
Okay, give me 1 second. Let me pull this up.
Yeah, that one. So it's I was kind of reading about there was a couple of presentations on Tesla Tech about how to wind the rodent coils to cancel out certain effects, and if you want to cancel out the magnetic field and make it more of an electrostatic field, then you need to reverse the winding on what you've just wound, so the actual current flowing through it will cancel the field. So actually, you've basically built a bucking coil against itself. But rather than it overheating, there's another means whereby it cancels out the magnetic field. And I thought, well, if it cancels out that, there's another school of thought that seems to think that the ether movement is, well, there's a book I'm reading at the minute by Dan Davidson, and he claims that the ether movement will not be cancelled out. It will be amplified, but the magnetic field will be cancelled out, and it won't get in anything's way. So he says it makes it a much better movement. Anyway, so I thought I'd do. So for every winding, there are 1,104 turns on each node.
Can you show that up to the camera real quick?
Yeah.
So everybody can
see
20,
it. The 24 nodes. I numbered them on that side, so to stop me getting lost as I usually do. But
it almost looks like a Mandela.
It kind of looks like an eye.
Yeah, or an iris.
Well, the distance, an eyeball. Yeah, but it's but I haven't done. I built Gerald's when Gerald was on with us a couple of weeks ago. He gave us that circuit. there was kind of a Bedini style circuit where you're impulsing the battery with the negative impulse.
Yeah.
Basically the back EMF, the discharge from the coil. And I got, but I couldn't get any usable resonant frequency out of this that would work within that system. But this one I did differently. Again, I'm playing around here, and there are probably huge holes in my knowledge compared to what Gerald knows. But I keep trying to associate the ratios of either the geometric sides or angles with the diatonic scale. So if you've got between a square and a triangle, it's 4:3. Hexagon to a triangle is 2:1. That's an octave. 4:3 is perfect fourth. And then you've got 3:2, which is the hexagon to the cube. That's not the cube, the square, and that's your 3:2. And then obviously the octagon on top. I like the octagon because it progresses in threes on the nodes naturally. So that gets me into my mod 9 as well. But the octagon is obviously 2:1 to the square. So the problem is that when I started winding it, I realized that I was losing the angles because of the rotation around the actual. Because what I was doing was starting from, where's the start? It was there. So start here, you wind around, inside, and then out to the first node, which would be 8 for a triangle, then winding back in here. So you've got a 360-degree rotation, but it's reversing. It's doing it in a helical pattern, but rather than closing the actual circle, it's then reverse winding and coming back in the other way. And then once you do one full round, then reverse that completely and actually wind over that winding as well to try and get this sort of effect of it. But I haven't had a chance to do anything other than that Gerald circuit today, which it didn't do anything. It's still a nice ornament.
It's interesting. It looks like the field geometry is concentrating it in the middle, and then it's spaced out farther on the ends. Yeah.
Yeah. Well, yeah. I mean, it's but again, tying in with the diatonic scale, I've got to set up the small mixing desk I have, an amplifier, and actually pump the same frequencies into it. What I was hoping to be able to tune it to get its resonance to a specific Pythagorean fifth equivalent, and then I can just take it down to an audible note. Because if I can resonate a coil at a, say, 70 or 80 kilohertz, then I can actually put on top of that or inside it many frequencies all the way down to maybe, I can go down to 1 hertz, and it doesn't go crazy like it normally does when you impulse around there. Normally you just get massive spikes and uncontrollable things going on. But when you actually have it in resonance at a tuned frequency, that is a harmonic of the frequencies that you're putting in underneath it, it turns into almost like a wave tunnel. It's a bounded area that it's basically encased by the resonant high frequency, and all the low frequencies you can see them spiking up and around it.
Wow.
But it's completely smooth, and it just looks like a tube on the oscilloscope. Cool. Whenever you see them all. I had, I think, 6 frequencies heterodyne together going through, and you can see them all. And I don't know why, but it turns out that the duration of each kind of wave packet is dictated. I thought it was by the lowest frequency, but it was actually the frequency that was sitting on channel 2 on the resonant frequency signal generator. So that's why I've got 3 of them. It's just to be able to get all 6 frequencies. But I thought I would I doubled up on the resonant frequency to make sure that all the other ones didn't take it over. So thanks anyway.
Yeah, you have to increase the amplitude if you're doing multiples.
Well, I couldn't increase the amplitude from the signal generator because I've been using Evo's boards, to I've got them stacked, so I can put in up to 6 frequencies on those boards as well. So they're impulsing, but it's high impulse. It's like I can throw in 1,000 volts per channel, 1,000 kilovolts up to probably about 1.7 kilovolts per MOSFET, and there's 6 MOSFETs. So if I wanted more power to see what that did, it's available. Basically, that's why I used its boards. But the biggest issue I have at the moment is not being able to produce current impulses, because I've been using voltage impulses for a couple of years and I'm not really seeing what I want to see. And I'm trying to figure out how to get proper, without you having to use spark gaps, to get proper disruptive discharges, capacitive discharge, not coil discharge. So I've been harping on it. Well, I've been asking Evo to see if he's finished his circuit yet, because he's been building a proper disruptive discharge, but he said he's not finished yet. And I really thought with the ZBS driver, I thought, oh, we've got it now. Then I can really start to pump some current into it, because I'm thinking, okay, 0 volts, that means it's maximum current, right?
Yeah.
No, you have to get a one-way unipolar impulse that is a half wave, but it's a half wave going through 0 and up to from negative maximum up to positive maximum. And that's the half wave you need, that Tesla would have used in his systems to actually get the full longitudinal wave. It has to be unipolar. It can't be a half wave going up and down. It's got to be one way right through and then terminated. And that's what he was getting from disrupting the discharge, rapid discharge, using spark gap from the capacitors. So I just want it to be easier than that, and I'm sure there's a way. And I want it to be completely tunable, and I'm sure there's a way. So it's
what is your process for tuning, by the way?
Well, when I've basically using Evo's system, you've got an L1 and an L2, so you've got 2 primary coils. The first one is discharged into the second coil, and so between that discharge, you can basically put in a series capacitance tuning board between the L1 and the L2. It's depending. You either flip it on the high side or the low side, depending whether you want a positive impulse or a negative impulse. And so basically, the internal diode on the MOSFET prevents it going back that way, so it goes into the L2 coil, and then you can get the coil to resonate with the series capacitors, and that's where it amplifies that discharge. Well, that's where you can tune it properly. But again, it's
have your coils have at least 2 channels, correct?
Yeah, well, they're bifilar. But you can use them. Unifilar when you join them together for the L1 for the first primary coil to make it a faster discharge often is better than trying to make it, because you get much faster impulses. I mean, the impulse speeds were down to
I'm wondering if the method that I use to tune might help you.
Well, these are giving like 80 nanosecond discharges. I mean, they're really fast. The problem is that they are self-canceling, because they are either going, they're half wave impulses, but they're not going through 0. They're actually bouncing 0 and back down.
So they're not usable energy, but you're seeing the spike.
Oh yeah, I mean, the energy's there.
It's just, okay.
It doesn't seem to be usable
well, the reason why I'm asking is maybe cutting the circuits and going to like a more basic way of finding the initial resonant frequency, like I use, and just hooking it to a load and slowly increasing the frequency until you see a spike on the voltage output. That might be an indicator of where a good starting point is.
Well, I mean, I get the natural frequency of the coils, the natural resonance of the coils first. So I've got an idea where it is. But to be honest, as soon as you put it into the circuit, then you can completely
Yeah.
tune it to whatever you want. I mean,
Right.
if you can wrap it to make it close to where you want it to start with, then you need minimal capacitance
I was
to
just
bring it to where
wondering
you
because
want it. But if you're using a broad spectrum of resonant frequencies, and
Mhm.
it's easier to be able to tune it directly with the board itself.
right.
So
I was
it's
just
just a
wondering because
question of getting the right balance
sometimes
between the L1 and the L2.
right. I'm just wondering because sometimes circuits, they have a lot of variables involved, and maybe kicking it back to a more simpler method might help a little bit. I don't know. Just an idea.
Yeah, I mean, I'm game for anything, but I do want to try and concentrate on getting some proper disruptive current impulses from capacitors rather than
Well,
getting impulses from coils.
Gerald uses pickups in the center with coils.
That's
So
what I.
you may want to
Yeah,
try
no,
that
that's a good idea.
right in the center. Just get a what is it, soft iron, wrap the winding around it, and then do pickups in the center and the outside and play with them. There you go.
Yeah, because the
Yeah.
energy could be
So
most of the
yeah,
energy
so
could
you
be
can get the
induction.
field. Yeah.
Yeah, no, I was using those just to see if there was any indication of activity in the center of this one today, but absolutely nothing with that circuit. So, but yeah, I mean, it's just still looking forward to Gerald's presentation.
Oh, trust me, we all are. Like he's like forever away on that. I don't know, when he's gonna do it. I'd just like to see his stuff up to date. Like, you know what I mean? He doesn't have to do anything new, just kind of like where he's been and stuff like that would be awesome.
Yeah.
So just kind of tell us what he's working on, because it's kind of hard to decipher because it's all together. It's like in his head is a master plan, and we all don't know it yet.
No, that's fine.
Right, that's why I call him the Lord of the Rings.
Yeah. Well, it's a good mental exercise before he spills the beans. Let's put it that way.
Yeah.
Having a good look at all the variables that are there is quite interesting, which is why I built this in a toroidal form, because, as I say, nothing in nature moves in a straight line, and those coils, even though they're geometrically correct, are all straight lines. So I thought if I curved it around the surface and maintained the integrity of the angles internally, but as you see, that is not what happens. It's because we're using the rotation is creating almost like it's like an average kind of turn, no matter whether there are octagons, there's triangles in there's everything, but it just blends itself right into, and maybe that's a good thing for a different application, so I just haven't played enough with it yet, but it's not a complete ornament yet.
You have the energy flowing in opposite directions in the coil and either channel?
There is only one channel. It's a single
There's
wind. So because I just wanted to see how that field canceling would work. So,
but
it cancels beautifully so far.
Well, no, it's a beautiful wind. I'm curious to see what happens if you have multiple channels on that one. Maybe you have some kind of effect with 2 channels or 3.
You know what? I thought about making it bifilar to start with, but that was I didn't even know how much room there would be in the middle after I did it. I wasn't sure how far
it does look crowded.
how far we'd cross. But it's not really. It's all pretty much neatly against the actual form. So, but I didn't want to make the center too large. I wanted it to be proportional. So it's 8.1 wide and 2.7 and 2.7 in the center. So it's all everything's got to add up to 9. I'm obsessive about it.
That's a good thing.
Well, yeah, 9 is the gateway to the 0-point energy.
We're gonna find out, Ian. We're gonna find out for sure with your coils if you're getting those numbers in there.
Well, it'd just be nice to know, exactly the effects that Gerald is getting from his coils and how he's getting that. That would be nice to know. I'm kind of shooting in the dark, but still playing with ideas. So
yeah, he hasn't released all the details yet. He said he's got like 7 different instabilities. So I
Yeah,
guess
no,
we can only.
I researched, I saw all those instabilities and I researched them all, and they're very interesting. I can see exactly what's going on. Actually, I've got a friend at work here who he very kindly went on SketchUp, because I've been doing this on Tinkercad, right? So I'm no expert at formers, but I this one I made off Tinkercad, but it's a solid piece. I made one that's hollow as well afterwards, because I thought, well, um, if you're getting a field outside in the center of the field and the outside, I've tried it before with acoustic toroid coils about getting putting pickup coils within the actual inside of it, because normally in the toroidal coil, the magnetic field is contained within the center and rotates. And I thought, well, if I can get some movement in that using sound, then it should be able to be seen on the pickup coils. But I was obviously misguided there, or I wasn't doing it right. So this guy, he's today told me that he could actually showed me on SketchUp. He'd actually put the windings on the toroid for me, and he said I can do as many as you want, going to as many nodes as you want, so you can actually see the winds before you actually wind the coil physically.
Oh, that's cool.
And not only that,
That's
you can
cool.
actually you can add nodes of pressure points on it as well, that actually show you the concentrations of what you are assuming will happen within certain nodal points, and it will show you how those build upon each other and everything like that. So
Yeah, Marco
I said,
said
yes,
that
please.
there's like
I said, yes, please.
Marco said there are certain nodes on the donut that are supposed to be they're supposed to be like you ever see the surface of a golf ball, how there's small inconsistencies, it's not
Yeah.
completely smooth, those bumps, those inconsistencies, they help make the ball go farther. So it's like the same idea. He said there's supposed to be little nodes, on the donut. I'm not exactly sure what he meant by that, but that's what he mentioned, and that just comes to mind. I don't know. That's interesting. I wonder if you have any information on that yourself.
No, I hadn't really. I mean, I was speaking of the nodal form on the equator of the torus is basically just those are winding points as it stands.
Oh, I gotcha.
But actually, I saw Tesla Tech just a couple of weeks ago. They just released the videos from it, and I was able to see. You'd be really interested in this, Ben. There were two videos. The first two presentations were all about rodent coil wraps and different geometries within them, and also the first one was interesting, where he actually rotated. You've got the rodent symbol, which looks like two sine waves, basically.
Right, the fingerprint of God, where you have the infinity symbol.
Yeah. So what he found was that when he actually put the convergence point, which is 2/3 of the way down on the circle, right at the center of the V,
right.
Right. So that convergence point is the null point, essentially is 0. So which is in line with the
0 point
above.
Yeah.
Yes. But what happens if you then take a phi ratio 1.618 circle, that's 1.618 larger than the circle that the original symbol was in, and you take your rotation point as that center point of 1/3 of the way down, and you rotate the sphere 3 times 120 degrees, the whole thing forms a fractal of the first thing. And it was quite.
Yeah, I'd be interested to see that. I've never seen anything like that before. And then people are always coming up with new ways to interpret VBM or to use VBM. So I'm always interested in these new presentations that are coming out. Yes, definitely send me that.
Yeah. Well, then on the second one, they were showing physically how to wrap certain coils in certain winding formats and everything. And second presenter, I wish I could remember his name, but he said John Arthur designs rodent coils and builds them. He's obviously a good friend of his, and he'd broken his foot really badly in a trapped under a rock when he was trying to help some people out from under a waterfall, and they said that his ankle was so badly damaged in his foot that it was going to take probably 12 to 24 months with possibly 3 surgeries, and he may not be able to walk on it again. So his friend had designed a coil based on, there was 3 sets, there was 3 coils going clockwise and 3 counterclockwise at 120-degree spacing around a regular kind of rodent coil. And they put for the three coils, I'm assuming there was 3 separate frequencies going in. They put in, I think it was 256, 432, and 512, right? Just sort of like an octave with a perfect fifth in the middle. They put those into there, and they closed off the other 3 counterwind coils with some kind of air capacitors. I don't know what, I haven't looked them up yet. Cardiff capacitors. And he said he gave me a full treatment of this coil. All right. He said it hurt like hell. It was so painful. But he said after the 3rd day, all the swelling had gone down. He took the cast off.
Oh, hold on.
4 days. He was
Stop. We can't do any medical stuff on the show. Just,
yeah.
Just avoid it altogether.
Yeah, I do have a theory on maybe why that works.
Sorry about that, Ian. I had to cut you off there.
That's okay.
No
worries.
I'll talk to you about my theory off stream, but I do have a theory about that in the rodent coils. That's pretty interesting.
Yeah, no worries. Yeah. Anyway, it's a very, very interesting presentation, and it was quite, virtually unbelievable, miraculous. But hey, 7 days. That's all I'll say.
No, that's incredible. I love hearing stories like that, and that's why I'm doing research on the rodent coil myself, and I'd love to find more ways to wind it.
Well, it's trying to figure out what is being affected by what. It's like they had their theories. I'm not going to obviously, but he had a very sound reasoning for what was going on, and it made sense. But exactly how is it doing it, and what is it manipulating to make it happen is quite something else. That's what really fascinates me about it all. So I mean, again, it's like listening to Exotic Propulsion earlier. He's a smart guy. Wow. I keep wanting to ask everybody, is like, what exactly do you think it is that we're trying to manipulate?
The ether.
What is the substance? What is the substrate that we're trying to affect?
We're trying to affect the
because there's a fundamental thing that we talk about fields here and the fields there, and this does this and this does that. But what are those fields part of? What is the? I know we all call it ether, 0-point energy, whatever you want, and it's kind of hard to. Tesla said, "Yeah, okay, it's an incompressible fluid." So we're looking at fluid dynamics, basically, right?
And in another way to describe
when you rotate it at high speeds, then it maintains a vortex after you've stopped, and there's an inertia in that rotation that stays there as well, right? So, and I'm assuming that's why Alexei's Graviflyer, after he switches it off, it actually stays airborne for like 20-30 seconds afterwards and doesn't come down until it's basically finished being within the rotating field, or the rotating field dissipates enough for the effect to wear off, kind of thing. So if we're looking at fluid dynamics, then we need to get it moving in a certain direction. But if we could just understand a little bit more about exactly what it is. I know, Nathan, you try, but I still struggle to fully understand, because it seems to be a combination of things, but I think it's simpler than that. I think it's one thing, and the right way, by the right method, then it should be. And also, I mean, you have the colors, light breaks down into colors, and sound breaks down into musical tones that are pleasing. The colors are pleasing. They're just different scale versions of the same thing, which is why if you're trying to manipulate light, then why cannot sound carry light? Because it's directly related to it. So
Well, that's the thing. The ether is it's all time, matter, and color, and it exists in a dimension where there is no time, matter, or color. So you can think of it as counter space. You know, you have space, and when space expands, you have counter space that contracts,
yeah,
and that's the interaction
well, that's
between
kind
the two.
yeah. See, that for me is something different again, because
Well, it's all
if you've
modalities of
heard
the
of,
same
if you've
thing.
if you've if
It's
you've
part
heard,
of the
but
same mechanism.
if you've heard, yeah, I mean, it's space and counter space, and you know, the whole law of incommensurability that Ken Wheeler talks about. I mean, and I get that, but it's still not useful. It's still not really useful in terms of what we on this side of the veil are trying to manipulate, because it has to be something that is partially physical here, that forms the space that we are existing in, compared
No,
to the other side of the veil, that is that modality that we cannot exist in. I mean, I see that side. The other side for me is the spirit world, where they exist in all time but are limited by space, whereas we in this side exist in a vast space but are limited by time. So you got time space and space time. It seems to be that's the incommensurability. But
yeah.
the formation of space-time that we are in involves a specific mechanism, and that's what we're trying to influence to get it to move in a specific way. Because if it's a fluid medium, it has to, in some sense, exist, right? Whereas
Right.
the other side, I understand, is just a different frequent. It's a different harmonic vibration. I think, you know. I mean, it's like people see stuff all the time. You've got clairvoyance, you've got people, psychics, people who see stuff. They seem to have the ability to be able to switch their brain vibration or harmonics to be able to see different things that we wouldn't normally see in our space, because we're not tuned into it. Where some people just naturally are able to do it, right? But it means it's really it's right there. It's almost like it's part of the same scenario. But I don't think that's what we're trying to, I wouldn't want to try to affect that through
The
messing
only
around,
way that
because you know, nuclear bombs probably do, but I don't want to mess around with disturbing that side of things with experimentation here. So I am interested to know more about what that really is about, to make sure we're not messing up in that respect. But at the same time, I just would like to be more clear exactly about what it is that forms the etheric medium that we exist in on this side of the veil that we're trying to affect. You know, it's just saying it's counter space and space and this sort of stuff is not, it's ultimately not helpful. I don't find it helpful anyway myself to actually try and figure out what's going on. What do you think, Nathan?
Well, I think it depends on how you build your coil. Going back a little bit, you have to build the outside and the inside where they resonate together. That's very important. Then the top and bottom have to be 180 degrees out from each other. And you don't necessarily want them wide. You want them short, because you're putting in voltage, because they're constantly crossing. You're not going to be able to get enough amps in there to affect it the way you want to. It doesn't mean you're not going to get amperage out of it. It just means that you can't necessarily put it in there. You know what I mean? It has to develop on its own. The idea of the inner and outer coil is making it like a Tesla coil, where you can be able to get cold on the inside and heat on the outside. That's kind of the dynamic you're looking for, so that you can start to create a flow. And that's probably the most important thing right there. That's kind of the design that you want in your coil. So an outer, an inner, you want cold on the inside, hot on the outside, but you also want not too far apart, because you have to be able to get, with low power put in, you have to get them to be able to not necessarily cancel out, but they have to be just big enough so that they can affect each other, if that makes sense.
It does. Again, I mean, I'm leaning towards just the whole idea of plasma, as I've mentioned before. I mean, if they say now that it's an accepted scientific fact, apparently, that the universe is composed 99.999% plasma. So is it a plasma field? Is ether a plasma field? Because if it is, we know that plasma self-sheaths and it forms sheaths, boundaries around it, coherent boundaries that actually separate it from other layers of different types of plasma, whether it's hot, cold, or it could be millions of degrees here and it could be ice cold here. But the sheaths around them are so effective that they're completely insulated from each other. And so when you're talking about containing the fields that you're creating around the bubble and the craft, if you're dealing with a plasma medium, there should be a way for that plasma to be allowed to contain itself, because it does it naturally.
Yeah, but I don't want a plasma state. I want the state right before plasma. I want the static state. So I want it like if you're creating a just basically an anode and cathode here, right? You get it out, it's really light purple. It comes into a spray, you get in a plasma. Yeah. Just right off of that, it's absolutely nothing, but it's still doing it, right? That's the state that I want. That's the charged state. That's the one that I want.
Right. Okay, but I'm not talking about visual plasma discharge. I'm talking about the ether being plasma that is invisible because of its low density, right? I'm talking about when that type of plasma, even the invisible stuff apparently forms perfect sheaths around it to isolate itself from other plasma existence in its area. So what I'm saying is that I'm not talking about making plasma for show or showing plasma. I'm talking about what happens to the field. It should actually create its own bubble around it if it's given the right conditions.
Absolutely. I 100% agree it will. Right. I can tell you right now, Gerald's Coil does it.
Nice.
He's got both. You know what I mean? Nice. He's got a the way he does it, he's connecting everything to ground or to the pipes in his house, and it's holding in the field. So his ground is essentially connected to the Tesla coil, or not Tesla coil, but his primary or secondary, which is the one that's putting out the field to hold it in. The other one's creating electrostatics in it, and it flows right through the center and right around the outside based on the heat level. So it's flowing the correct way, just like that. But for if you want to say everything's plasma, it just means that it's not a heavy fluid in the beginning, but it'll start to become one in the center. The center pulls off a heavy fluid there. That's where it comes in, but you have to get a lot in there to do it. Like we don't generate the stuff that things do in outer space. You know what I mean? Not in these little coils. Not we haven't pushed enough into them yet.
Sure.
So but I do think there is a state, just like they tell you in UFOs, if you go around them and they or people tell you stories about them, how the outside is like a bluish, you know what I mean, or a greenish blue or an aquamarine color. And I think it's the molecules themselves combining and tearing apart, you know what I mean, right there on the outside field that they're created. So that's my opinion anyway.
Yeah, I mean, I recently read one of George Adamski's books on his interaction, and and he touched the outside. He accidentally touched the outside of the craft before. It was an accident. He wasn't meant to, and it hurt. Apparently, it took quite a blast from it as well. So it also was very charged. In that case,
I have no doubt. If you're running electricity in a craft, man, you're gonna get zapped. It's never gonna feel good. No, I've yet to have a time that it did. That's for sure. Made me rethink my life a couple times, but I've never had a point where I was too happy about it. Maybe afterwards when I was laughing about it, you know what I mean? But
especially if it's between your legs, right?
Yeah.
That was crazy.
You gotta find humor in all the things you do wrong, you know what I mean? Just a little bit. So when you accidentally zap yourself and you make sure you're okay, you can laugh about it. So
Christmas tree ornament.
Yeah. I don't know about that, man. I think you got something there. You just, put your pickups in it and, you know what I mean, see which directional flow you get. That's what I always say about these coils. People You need to understand there's a flow to them. And the flow could be in the layers that you build. It could be in how they cross. You know what I mean? Because everything's going to give you a different amplification point, and you're going to have to figure out which one's which. You know what I mean? So maybe in one, maybe in one wire you run just frequency. You know what I mean, with very low amps, and then the other one you put a few amps in it and low frequency, and start to see the combination of what they do. You know what I mean? Going around every different winding that you put in there, and see what the end result is.
Yeah, no, for sure. I mean, I'd like to have made it at least tri-filer, but I had no idea. I just wind it single filer, so I'm stuck with what it is.
I'm impressed that you got that thing done, man. That's a lot of putting the wire through the hole and getting it to wind around.
Yeah, I guess I'm a bit of a coil masochist.
I lose patience on those things.
Well, I, on the other hand, seem to have the patience of a saint, so so I'm told. So, but anyway, it seems necessary to get these things done, and not to be too disheartened or too bummed out if they don't do what you thought they were supposed to do. But I haven't even started on it yet. So, and I've got, since we've all been chatting about different things, I've come up with a lot of different ideas for experimenting with the other coils as well.
Yeah.
So,
well, I think the coils are the way to go because they're the answer to what we need. All this spinning stuff and motors and all this stuff, that's all got to go. You know what I mean? That mechanical side to it just got to go. I don't like it at all. It's way too hard to control. It's so much easier when you get the coil dynamics right. You know what I mean? Mm-hmm. So
But I think if you want something to physically spin, if that's required in the fluid medium, whatever it is, I think a plasma flow or spinning plasma makes sense, because then that is something that you basically form, and it self-contains as well. And I suspect, I don't know the full detail, I think that's what Nassim Haramein and his guys are all up to as well. Have you seen the little flyer they have? It's like it's two hemispheres. Basically, it's a sphere, and it's wound counterclockwise and clockwise, or the other way around. I can't remember. And you see in the center, they've got a plasma in the center, glowing, and there's a whole field around it, and it shows you the way that the fields are actually counter moving as well. That's part. I mean, it's a real image of what they're working with, but it's not. I mean, the fields are just superimposed on it to give you an idea of how they see it as working, kind of thing.
The one I did see was in a vacuum chamber. I saw the one in the vacuum chamber where it actually had the the cup magnet you have with all the little magnets inside of it, the 3D printed thing with all the neodymiums in it. And they had that one suspended on top, one suspended on the bottom, and they ran it through, and it created a singularity point in the center, and then it got bigger and it just grew like this. You know what I mean? To open up like this, real big in the center. And then on the outside, it showed a ring on the outside.
Right. Huh. No, I didn't see that one. This was a very recent one. Just
let me take a look, and I'll see if I can't pull it up for you real quick, so we can just get a quick.
I know everybody has to keep things like this close to their chests for obvious reasons, right? But you don't suddenly go and call yourself the International Space Federation for no reason, right? Unless you've got a really good reason for moving country, getting as neutral as possible, and setting up a completely new labs and everything away from the US, where that's all your research has been done before. So it's interesting.
Oh well, that would be nice.
Otherwise it's one of the biggest bluffs ever. But I don't see it that way. I think they got something going on. So
yeah,
but they are rotating, definitely creating a plasma plasmoid perhaps in the center, which is doing all kinds of stuff for them within the
Yeah,
fields.
that's why I wanted to find the picture, because it absolutely shows exactly what we're talking about here. Oh man, I have to go back. I think it was a couple days ago or a week ago that I pulled this up, and I don't remember, right offhand where it was at. Let me.
Can I share any pictures with you? Is that possible?
Yeah, absolutely. What did you
How
want
do
to?
we do that?
Oh, hold on.
Well,
I found it.
I actually have. I don't have the movie, but I've got some stills of the same presentation that gives you an idea of what the setup is.
Okay, give me 1 second. I just want to show this, and we are
It's
good to
called the
go.
vacuum.
And then
The
I'll pull
vacuum
up your
flux
stuff for you.
generator. Yeah, it's the vacuum flux generator. It's called.
So here we go.
That looks that's those are the primer bowls. That's not Nassim Haramein. That's what's his name? David Lapointe.
Yeah.
Because those are the same primer bowls that I made to try and influence the energy. And I put the pizza disc inside.
That's what I was saying. Those little.
Right. Yeah. So no, this is how do I share? I don't know.
Go down to where it says present.
Okay.
And then click it. And then is it a window? Is it a picture, or is it a video?
Just says I slides, video, or share screen.
Yeah, go to the video. Just make sure you mute it in case they get us for a copyright.
Oh yeah, these are just photographs.
Oh, okay. Well, then you're good to go. So,
okay. Slides.
Once you click it, you should be able to click window if it's a photo, and then I'll pull it up. So do it this way. Just blow up one of the pictures and then hit present, window, and then pick the picture.
Yeah. I'm sorry. Okay. Can you see that?
I don't have anything on my screen right now pulled up.
Don't worry about it. I'll figure it out.
Like I said, if it's just a picture, just blow it up. You know what I mean? And then you hit present and go to window. It should be the center one. And you click that, and it'll show you the different things you have pulled up on your computer, and you just pick the one you want.
Okay. All right. So I go present. Or if I just share screen and then just show it that way, does that work?
Yeah. If you can get it that way, go for it.
You see that?
I can hear it. I just don't have anything on my screen yet.
Okay. I kind of followed the prompts there, and I should be sharing my screen. Is that right? Who knows?
Yeah, I don't have anything right now.
There we go. Fantastic.
Oh, here we go. Now I see something on your screen.
Okay. There.
Oh, that looks cool.
That seems to be the latest. You got that? Yeah. So you have the counterwind two hemispheres, and this is just showing the central kind of orb of it, and it all looks like copper windings around the sphere. That's why I saw this, and I saw what um, Sean had made with his Tesla coil, and I thought, "Ooh, that looks familiar."
Oh,
That's why I
yeah.
asked if he had done it in two separate. I asked him if he had done it in two separate hemispheres because, and if it was counterwind the way that these are done, then I thought that might have some interesting effects.
Hmm.
And let's see, I'll just.
So is this
Yeah, that's the actual what it's in. And there's capacitors and all kinds of circuitry all around it, and I have no idea what's going on there.
so that's a real picture of the actual flow then?
Yeah,
Okay.
that's a real picture, but I still think that flow, you can see the way it's kind of been superimposed.
Yeah.
The toroidal field around it is, but that seems to be what they're working with anyway now. So it's
That's
interesting.
very cool.
Yeah. Yeah. Oops. Yeah, that's just a close up looking inside at the what's plasma form in the center of it of some kind.
So it's all pulling it into the center. Is that what it's doing? It looks like it's flowing around and pulling it in.
Yeah,
Or is it-
yeah, that's well because I presume that's forming basically plane of inertia,
hold on.
whatever you
That-
want to call it.
That's a wired ball. That's not a solid ball. I didn't notice that until I see it up close. That's like
Yeah,
just like
it's wired.
Sean. Yeah.
That is wire wind, and it's horizontally wire wind, obviously, but wind in opposing directions, so that you're getting the vortex coalescing in the center.
Well, yeah, Sean can do that. His ball is built
Right.
in two pieces, two halves that he glues together to make it the one
There you
center
go.
ball. So he can absolutely do that.
Cool.
So is there anything else in the center of it besides the winding on the outside?
It doesn't show. It just talks. It's like it's just a flyer that lasts about a minute. It's not even a minute, but I just grabbed a few stills of it basically.
Oh, that was really cool. Yeah. I didn't know that. I was talking to Sean about putting the center, to be the discharge point. And it kind of looks like that's what they're doing there. Is the center has that and then it's pulling things into it.
Which suggests that it's an implosion point.
And that's what we were talking about with his Tesla coil, because it wouldn't touch the glass that was next to it, where his DC touched it, his AC touched it. But when you wound this the round coil, it wouldn't interact with that crystal cylinder that he had sitting next to it. But it would create these beautiful swirl shapes that look like they were pulling in instead of pushing out. So let me pull that up for you, because I probably have it right here. If I can go to it. Let me go. Sorry, my whole computer's like backwards right now. I had to reset the whole thing. So let's see.
Did you have a Gravaflyer moment with it?
No, I had somebody hack it, and
No.
they don't realize my files are all on my other computer. I don't keep them on this one. This is just for the internet stuff. So yeah, they really didn't get much. So yeah. Let me see. It's getting close. I'm in the right folder. So come on, where is it? Here we go. let's take a look at this, and we'll just show the field right here. Okay. So do you see the discharge in it?
Yeah.
So what it looks like is that the swirls here, I don't know if, let me just pop it on this one. You see my mouse barely. It looks like they're going inwards when they swirl and tunneling backwards in.
Right. Right.
And instead of it looking like it's forcing it out, you know what I mean?
Yeah. Eric Dollard has said this before, that it's, I think it depending on specific polarities. I'm not even sure if that's right, but anyway, he's saying that a lot of this is actually being sucked in. It's discharging outside and going into the point rather than the other way around. It always looks like a discharge, but yeah, if that's imploding in, that could be very interesting, huh?
Yeah, it looks like it must be due with the shape that he built it in.
And it also looked like they were vortexing in as well.
Yeah, absolutely.
Yeah.
So trying to find that spot. I don't know if I'll be able to find it.
Plus, with so many wines, it's very electrostatic, isn't it? The actual output.
The output of, I don't know. Be honest with you, I've only seen pictures. I haven't been near it. So you would have to pretty much get a hold of him to figure it out. Yeah, I'll show this real quick just so everybody has a reference of what we're talking about here about Sean's Tesla coil. Well,
the color of those discharges were very purple, so that denotes high charge as opposed to high current, right?
Yeah, he's using AC, I think, on a half bridge.
Okay. Oh yeah, that's I saw that he opened up the cone for the primary.
Yeah.
Oh wow.
So just imagine that in the center, it would be more like what you were looking at in the other video.
Right.
I'll show that picture of his winding so you could see what it looks like. I think you saw it already, but I'll show everybody else if I could see it. Oh, hold on. Did I just see that? I just did. This right here is, I'll show this one, is the one where it does it, like it shows on it.
Right.
And his other one, the round one, won't interact with that piece of glass at all. It won't go anywhere near it. So he must be having it pull in, and this one's definitely pushing out.
Huh.
So, yeah, he's definitely got something different going on there, and I don't know why it's not right in front of me. Here is the shape of it. I'll show you that. Sorry, it takes a minute just to click around here. So it's got the same. Wow. So kind of like that video, that picture you showed, it's got the same windings in it. And they're all sliced. And Sean built it, like I said, in two halves and then glued it together. So if he wanted to create the singularity in the center, he absolutely could.
Right.
So
interesting. Yeah. So it looks like it's been sliced down the center vertically rather than horizontally. Would that be right?
He sliced it along
the former.
Yeah.
The formers.
Yeah, it's on each slice, so it just sliced on one of the slices.
Right.
So it would be vertically, not horizontal.
Right. Right. Mm.
So let me see if I can't find that for you while you guys talk for a minute, because I know it's in here.
Hey, so Ben, was your new amplifier not up to it?
Yeah, it wasn't powerful enough to spin this neodymium sphere like the Insignia receiver. but it does still work with the circuit that I have, so I can still do some testing with it. So
Sure. What wattage output is it?
let me look it up. I think it's only like 200 or 300 watt. Let's see.
What was your insignia?
The Insignia was like 400 or 500 watts. It was a little bit more powerful. So you could tell like it was right on the threshold of spinning, but it just wasn't there.
Yeah.
Got so many tabs open. I need to close some of these. All right. So this was AK45 home audio amplifier stereo receiver, max 300 watt, 2-channel. So I think the Insignia was 400 or 500 watts, something like that.
Okay.
It might have been even a little bit more powerful than that, but you could tell like the gain just doesn't go up high enough when I'm using the fan and stuff.
Right. Okay.
I'll-
Your reason.
Yeah, but it's a lot smaller than the Insignia, so I can do some neat stuff with that. I'll just have to adjust. And I'm gonna order a more powerful one for the neodymium sphere because they're not that expensive. I think I paid like $30 for it.
Yeah, go to the secondary market, go to offer up. You can pick one up cheap.
Yeah, just get a second. Yeah, exactly. Yeah, and I can get a more powerful one real cheap. No biggie. Just that's why we test these things out. Theory only brings us so far, like Nathan always says.
Yep. So Ian, you see it where it won't.
Yeah.
It won't
It's
even
not interacting with. Huh.
Yeah, it's really cool. I've never seen anything like that.
You saw the other one; it just kept going right to it, and this one doesn't want anything to do with it. So yeah, he may have it going backwards and going into it on that one because of the shape, which is totally trippy.
So there's an attraction repulsion effect going on with the glass.
Well, it's not interacting with the glass at all.
So what is it repelling?
Well, hold on.
Well, I think
normally you have a field that goes out in a testicle, right? It goes out, but this one looks like it's pulling it in.
I see what you're saying.
It's not interacting with the glass. It doesn't like it.
Yeah, I see what you're saying. Okay, that makes sense.
Go ahead, Ian.
No, I was wondering what Sean, what his thoughts were on it. Is he
in chat? He might be able to tell us.
No, he's not in chat. He had to leave early. No. He was saying he didn't know. He wasn't sure. Okay. He was going to investigate it a little bit more and get back to us. But he's built like 2 more coils. Since then, man, this guy's got. He uses the square wire instead of the round wire on some of them. So he's saying it gives it more capacitance in there, so it's giving it a higher value. So, or a lower value. I don't remember which one they said, higher or lower, but he's got it to work. And he's got all kinds of different testicles going on now. So I can't wait till he starts his channel because then we'll be able to all see him as much as we want.
Yeah, I think I saw him post that he just wound another 5,000 winding Tesla coil.
Oh yeah.
I'm not sure what type it was, but yeah. He showed me one that burned out. But I thought, oh man, that is toast. And apparently not. Apparently you just scrape off the outer layers, clean it all up, get rid of all the carbon deposits, and then epoxy it back up again, and away you go.
Yeah. He said he's looking for a million volts out of one of those. Okay.
Yeah.
And he's got this ZVS board. So instead of the regular 2 MOSFETs, he's got 6 on there. It's like this big. And he's trying to get the 1,000,000 volts out of it. So, and he said he just put it on his desk. I'm thinking, go outside, 1,000,000 volts. You may need some fields to go. No, just put it on his desk. So,
all of his electronics.
He said he wanted to hit it in a piece of acrylic and just hit it on the top, and then it makes some kind of a lightning thing that comes out of it, and then you see the lightning bolts in it in the acrylic, and then they keep firing off the electrons in there. So,
Oh, wow.
yeah, that's what he's looking for. I could probably pull that up for you as well. He definitely got something else, man. So,
Well, getting that many wraps onto a coil that's only 4 to 6 inches high, like 5,000 wraps, is quite ingenious, really.
yeah. Well, it's not much different than an AC flyback in the way he winds it. It kind of makes you wonder. So, okay, here we go.
What? So it's done in layers?
Yes, it's done in layers. So it's exactly like a flyback. So you wind it, and then you go on to the next layer and start winding. You go on to the next layer. So it's the same thing, and he's getting it to oscillate. And he was telling me that everybody he talked to and asked him about it absolutely said it wouldn't work. And then when he does it, obviously it works. You know what I mean? Because he just saw the wire as capacitance instead of the wire as a feature, as a directional feature. You know what I mean? Which changes the whole ball game. So anyway, here we go. Lightning and plexiglass. All right.
Man science.
Oh, let me skip past that part. I just want to get to the good stuff.
This is why sometimes when you have videos like this that are a little bit longer, or how long is this? 4 minutes? Oh no,
Yeah,
this isn't long. Never mind.
Hold on.
It's hard to see.
Wow.
Oh wow.
That's what he wants to do on his desk.
Right. So wow, it's still, that's amazing, huh?
Yeah, what the hell?
So how much energy did it take to do that?
Is that piezo?
I don't know what it is. I'm sure they tell you in the video. I can link the video. Let me just take it off of the share, and I'll put it in the chat. But
That's nuts.
that's what he wants to do.
That's
I mean, I can't say I blame him. It's absolutely cool.
No, yeah, no, that's what I mean. Like it's awesome. I've never seen that before.
So there you go.
Huh.
I'll paste it right in the chat.
Nice.
But yeah, he says he
Your
needs
own
a
light.
million. He said he needed 1 million volts. So I would imagine it works somewhere close to that voltage. I mean, I don't know how you hold that, but you know what I mean? If he's getting that out of it, you know.
And it's like you can see the electricity going off after he takes the tool away or whatever he's doing at the top. Like it's still arcing, and that's the cool part. I'm like, what?
Yeah, he's definitely that's definitely something to look forward to. That's for sure. With knowing him, he'll be able to do it. So I don't doubt that at all.
Yeah, for sure.
Yeah. So what is he using at the top? Does he tell us? That little tool he puts up to the top?
Oh, I have no idea.
Well, that's whatever's discharging the lightning into it. So I presume it must be the equivalent of a lightning bolt.
Just
so
a
you've
probe.
basically caught your own lightning strike in an acrylic cylinder.
Yeah, instead of like a piezoelectric crystal, normally you'd have to crush it to get that effect, right? Like hit it with a hammer or something.
So check this out. This is the Tesla coil I was telling you about earlier with Charlie C. He hooked his water pump to it. It's just got a cool factor to it. You know what I mean? Anytime you could put a water pump to it,
pardon the
green.
Pardon the pun.
Yeah. So, I mean,
nice to meet you.
not only that, he's getting good sparks out of it.
Yeah, that's nice.
Huh.
I like how they're straight sparks. They're like really straight arcs.
Oh yeah, well, you're gonna get that with that AC quarter bridge. I think he's using.
So that's all to do with that. The different kind of sparks that you get, the different shapes.
Yeah.
That's so cool.
So, but that was something that Sean was helping him with. It just, Sean's the expert in Tesla coils. When you when you want to build some sparks, he gave me a circuit, and I got it sitting over here, and it looks completely backwards, but it's completely right, and far beyond what I would have thought it was.
Yeah, I know it's I don't think it's well known, but I actually saw this on a presentation from the STC. As Adrian Marsh, who's a British guy, and
Okay.
he's produced these fire ratio. I think it's called what's it called? Something Dragon. But anyway, it's the specific shape of discharge coming out of the top of his Tesla coil. But he actually he tunes them so that there's the series and parallel resonance using a VNA, the vector network analyzer. You can actually see the position of the two different resonant features of the coil, and they're different. They're in different places, and you can actually tune it to bring these and align them so that they're almost in the same place, and it makes the whole coil that much more coherent. I just wonder if Sean does that as well. Has he mentioned it at all?
No, he hasn't
It's
mentioned
different.
that at all.
It's a very different kind of way of doing it. Like, you need a variable capacitor, and it's only picofarads basically, the variable one that Adrian was using. But it's impressive. I mean, he's a PhD in this stuff, and he approaches it completely scientifically.
Hmm.
But you could see from the software, from the network analyzer software, you can see exactly where the series resonance is and the parallel resonance is, and they go in opposite directions.
That's so cool. If you have a chance, if you find the link to that, send it to me in my email, because I'd love to look at it.
I will. Yeah, for sure. Yeah.
Because that just sounds
the golden dragon. It's called
the golden dragon. Is it on YouTube?
I'm not sure. His channel is on YouTube, so he has a ton of stuff there. And I know last year they got one of those $50,000 cameras so that they could take slow motion recordings of both what's this guy named Jeremiah, was it, who was building the Tesla turbine, and
yeah,
they got some serious wattage out of that. It's so incredibly anyway, but it's because it uses it's not using any form of friction to actually flow the air through it, and it's based on two different pressure systems. One's got low temperature going, and it turns it into steam, and the steam passes through the turbine blades, but they're positioned like that, and it goes in between. It doesn't actually push them. And it actually basically forms like a vortex within all these blades, which are specifically set apart. But the only way you can actually balance it is by literally grinding the outside of all the discs to make them absolutely perfectly the same.
Oh, wow.
Because it runs at some huge, like 50, 60 or more thousand RPM. It's really fast, but it's incredibly effective. But anyway, yeah, so I know they got the camera to be able to see that, to be able to tune it better. Because when you can see where the wobble is in any of the blades, then you can actually tune it out by just grinding that section. But they also were going to use it for his Golden Dragon discharges, to look at the discharges in real slow motion. And you can see sometimes when they're coming from the outside in or inside out. How they he actually has a whole, I'm sure it's on his website, Adrian Marsh, AMI. I'll look it up. But anyway, but it's but he actually shows it how it dances, and he shows that the discharges have specific kind of patterns to them, where they rotate this way, then they'll rotate that way, they'll go straight up and then start again. It's almost like a dance.
That would be really cool to see how he interacts them and builds them. That'd be really helpful.
Oh yeah. Well, he builds his own high voltage power supplies, everything, and the amplifiers are he makes everything himself. He's that way inclined. He's good at it. But he was working side by side with Eric Dollard, helping him build stuff and all the rest. He's in that league of knowledge kind of thing for all those systems and Tesla systems and everything. Yeah.
Older systems, those are usually the best ones. You find the good parts. You know what I mean? Not the cheap parts that everybody breaks, but the good ones in the older systems. I love those things. So
They don't build them like they used to, gentlemen.
No, they don't. Not at all. It's like the MOSFET you find in your tube TV is 10 times better than most MOSFETs they sell on the market today. 1600 volts. Yeah.
They got to be really fast as well.
Oh yeah. But they stand up to a lot more. You know what I mean? They don't break every time you turn your machine on. So
right.
Yeah.
My Game Boy back in the day, it was a brick, but it turned on every single time. I could drop it and it still worked. You know what I mean? Now I got a Steam Deck and I'm so afraid to even set it down hard.
Yeah. Oh man.
Yeah, really.
Well, they probably knew with those Game Boys back in the day, they'd have some time in the air, if you know what I mean.
Those were military grade Game Boys, man. They were ready for war.
Yeah.
Get sand in them and dirt, and they'd still work.
Yeah. My first Nintendo I had, that thing worked forever.
Yeah. Just give it a little blow it in a little bit, and it's fine.
So I don't even know what that did, but it seemed to work.
I don't know either. I don't think anybody does. I think it's still a mystery. One of those mysteries.
Huh.
Yeah.
That's so funny, man.
Jason and Ben, listen, I'm really sorry. I got to be up at Sparrow's Fart to go back.
Yeah, not a problem, man.
Really early. So I'm going to have to bail out and get something to eat.
Yeah, that's cool. Hey,
we appreciate you coming on.
Thank you very much, Ian. I appreciate it. Thank you.
Yeah, thank you.
Thank you for coming on.
Nice coil designs.
I appreciate the conversation, man. You're awesome.
No, not unlike yourself. Thanks.
Thank you.
All right.
All right, Ian. Have a great night.
Thanks.
Oh, man. This turned out to be a really good show, man. We got a lot of cool things going on here, man. I really enjoyed it. We got a lot of good guests that came on and everything, man.
Yeah, and a lot of great people in chat here. We got a lot of people watching us right now, 46. So let's also give it up for our awesome audience.
Yeah, there you go. Right there. Always cool, man. I love doing this show, man. It gets better like every time that we get it going. You know what I mean?
Yeah, we're building a legacy here. We're networking with other people, and we're building something big. We're working on a big project, and then that's getting this information out. Triggering the algorithm so more people look up 0-point energy or anti-gravity. Those keywords. Just keep talking about it. This stuff is real. It's not some myth that's should be laughed at or ignored. This stuff is real. So share to anybody who you think would be interested in that kind of stuff.
Yeah, you know what? We got to get them all in the same room. Like I don't like the fact that Gerald wasn't here, so we got to figure out what happened.
Yeah, this was kind of intended to be like a roundtable of everybody, so it's hard to get everybody. But when we do, we definitely have to get when we can network everybody together like that. We'll definitely have to do a show like that.
I want to see what Makaba says when Ian's in the room. You know what I mean? And the cross conversation that goes on there, and then Gerald comes in and gets right in the middle of it. That's just, dude. I so want to hear that.
We have on here,
and then I want to also hear Sean get into it. You know what I mean? With all three of them, and I think that would be just amazing if we can get them all together at the same time. So,
how many people can we have on here?
We could. I think it's 8, 6, 8, something like that. We got enough room. You know what I mean? We get everybody in here in the conversation.
Yeah,
You know
it's
what I
just getting everybody together on the same day. That's the hard part.
Yeah. They're in different time zones too. So Makaba's in England, the 8-hour difference.
Right. Yeah, that's hard. Yeah, I know something like that, even like it's hard to get him live on stream to the point where, I know I was discussing with you even having a pre-recorded session with him just because it's so hard to get him on a live.
Yeah. Well, you know what? I usually do that one early in the morning. There's some people, you know what I mean? Just go live with early in the morning. But
that's a good idea. And there's most people just don't even catch the live. They watch it on a video on demand. So
watch on the playback.
Yeah.
Right on, man. Well, you know what, Ben? You got anything else going on there?
Not really. That's all I got going on. I mean, I do have the coil that I was winding yesterday. I didn't measure it yet, but
he just walks away talking. Oh,
I didn't
man.
measure it yet, but
hold on, we're getting the top half. There you go. Get that bad boy up and wound. That'd be pretty cool.
So when I have time tomorrow, actually, I'm gonna measure it out. We're gonna times it by 24 and then times that by 4 to produce our interference pattern. And yeah, that should tell us exactly how much. I mean, I think it's gonna be around 1,200 feet, but I could be wrong.
I give a shout out to Terran Earthling out there. So he's out there, and then I don't know if you caught my conversations with Joe about that rock that he has. That thing was pretty cool, man. He's got a rock that starts putting off fields just out of the blue.
No. Sum it up for me. Give me the cliff notes.
So basically, he found a rock in the river, right? And when he brought it home, it started having special properties to it. So it would start putting out a static electric field and start messing with everything in his room. You know what I mean? It started messing with Alexa and everything else that's in his room. So he then started cutting cores out of this thing, and it started having more and more things happen to it, right? So every time he messed with this stuff, it did something different. So
what kind of material is it? Does he know?
You know what? He was saying there's several different things in there. There was stuff in there that could build a battery. You know what I mean? There's stuff in there that had it was cavernous material. It also had piezoelectric material in there, like quartz.
So it was a combination of things like we see in those crystal batteries.
Yeah. So he had something special there, man. And just the conversation with Joe is absolutely fascinating. Anytime he comes on. So
that's
anyway.
Crazy. Yeah, no, he definitely needs to, if he can, take a sample of it under a scanning electron microscope and see what's going on.
He got rid of it. He's got a couple small samples that he showed that still do stuff, but all the big samples are gone, unfortunately. So
that is unfortunate, but that's very interesting. I mean, that would be like evidence to support in crystal battery, where he makes like a combination of I think it's ground up piezoelectric material and other sediments that when it dries, it hardens like a cement, and when it sets, that's the voltage it outputs, and it just always outputs that, and it doesn't go down.
Yeah. Well, that's kind of one of the keys to doing all this stuff, man. That's why we're the Fringe think tank. We got to look outside the box and see who's got what. You know what I mean? And
imagine having a military grade battery that you could just smack on the smack on the end, and it just keeps on going forever, and you got an output.
Yeah, I don't even know if you need to smack it. It was like a solid state deal. You know what I mean?
That would be for dramatic effect. You know how you like smack a baby?
Yeah. There you go. Got it.
You gotta have the dramatic music with it too.
Yeah, I guess. All right, Ben. I'm exhausted, man. If you got anything else, share it. If not, man, we're going to be on next Monday, 3 o'clock on the West Coast and 6 o'clock East Coast. and come out and check us out again. I don't know who the guest is going to be yet. We're going to line one up and we'll put it out there. Ben, you got your coil class going on next week as well?
I'm planning on the 8th. I'm planning on the Sunday the 8th, just because I need to make sure I have enough coil. So I have a couple of spools, but I want to make sure, like I used a little bit. I had a 1200 foot spool, but I used a little bit of it. So if it turns out that I need a little bit less than 1200, we might be using that one and doing it this Sunday. But as of right now, the date is the 8th.
Okay.
And then you have a new podcast coming up with Gerald, right?
Yeah.
On Wednesday.
Gerald and I are going to do Wednesday. We're going to build simple circuits. So we're going to build Slayer Slider Tesla coils. We're going to build feedback circuits so that you can capture the feedback in it. Yeah. Just all kinds of little things that go with these coils and the Tesla coils and all the stuff that we use in all of our adventures. We're going to build them, and we're going to go, point by point on it. We're not going to do the theory on it. We're just going to flat out show you how we solder it together. And then we're going to demo it so that you can see how it works. So everybody can start to, real simple things, five parts, and that's
and I like how you're doing it live so people can ask you questions and interact with you. No, that's cool. I'm really looking forward to that one in terms of being a fan of your channel. And, I'm just going to be an audience member, just, like watching, learning.
Yeah. Well, it's something that everybody wants. They all want to build the circuits that we're building. So why not put it out there? You know what I mean? So that everybody can participate. They can build it, see what it does, doesn't do. You know what I mean? It might be a breakthrough for somebody. It might just be something that they've already done. But it's always
sign me up for that.
Put it out there. Yeah. Because there's not a lot of it out there. You have to.
Yeah, exactly.
Yeah, you continuously have to put different things together to figure it out. There's not like a library of knowledge for this stuff.
Yeah, and the few stuff that is out there, the few videos that are out there, the people presenting them, they don't do a good job of explaining certain things, for like replication. So that's and then a live stream is a good idea to rectify some of that too, because you can interact with the audience and they can ask questions and stuff. So
yeah, well,
I like it.
Yeah, we can show them the different parts, and what I'd like to do is just put it in the description where the parts are on Amazon or something. You can look them up. You can buy them. You know what I mean? That way you have somewhere to start. You have a starting point. It's not a guessing point. And
what I recommend is putting together maybe a simple document with some images and text, like a presentation, if you can throw something together like that real quick for everybody to look at.
Oh, well, I don't have anything right now, but when we do the Wednesday, I will.
Yeah. If you have any diagrams or anything that you could add that they could follow around.
Like I said, we'll do point-to-point diagrams. So no theory diagram. We'll just do the point-to-point. So where I put the wire, you solder. That's it. So with no confusion. You know what I mean? You can draw it in your fancy ways to draw schematics. That's fine. I'm just going to do it the non-confusing way so that you're going to be sitting there with a wire and a soldering iron and you know exactly where they go. You know what I mean?
Right. And then I need to go back into my live streams and do this, and but I like for workshops especially break it up into chapters, after you're done with the live stream.
Yeah, well, hopefully it just be, one thing that we build and then we discuss it. You know what I mean? That's kind of where I'm getting to on it. Build it, discuss it, talk to people out there, see what they think about it, what they want to add to it. Maybe there's a second stream that comes out of it, on the next week or something where we add a secondary circuit to it.
Right, like a bigger project.
Yeah, because that's the way normally these things work. It's never just one circuit.
Do you have any idea what the circuit you're going to be working on for Wednesday is?
Yeah. Gerald's got a book of them, and I don't know which one he wants to pull out. I do have a beautiful Slayer Exciter circuit. I'm updating it so I can run it on my gold coil you see over my shoulder right here that I know is in perfect resonance. And I'll run a Slayer Exciter on that, and I'll see exactly how far I can push that thing. So
awesome. I have a Tesla coil, so I'm ready. I got some of the components already. So. But do you plan on? This is my last question, by the way. Do you plan on doing any Bedini circuits?
I actually am planning on doing a Bedini machine. Nice. So I'm putting together parts now. Circuitry's not a problem. I'm just looking for a wheel. That's where I'm at.
Right, the flat, yeah.
Just the bicycle wheel. So I've heard metal and I've heard aluminum. So I might just buy both. And then when I have both, I'll put them both on there and run them and see what they do. Coils, I already have the coil stuff already here. All that, I can wind it. I can get the circuitry together within a couple days. That's not a problem. But I definitely just want to do that. Just that bicycle wheel circuit that he does. That's all I want to build.
Yeah, I do too. So sign me up for that one too, man. I'm excited.
Well, I figure, why not? If we're all going to talk circuits and stuff and all this stuff, we might as well build something that everybody's into. And a lot of people on my channel are into that Bedini thing. So we'll do that because I want to show those spikes. You know what I mean? I want to take out my oscilloscope and put it right on it. I want to find it and I want to show it.
Yes.
Because I can definitely find the ring in it. You know what I mean?
Yeah, like when Eric Dollar was talking about it, he had old equipment. He didn't have like an oscilloscope there to show you, did he? Like in any of his videos? Not that I've seen.
No. And I don't know.
Yeah, that visual.
Because I worked in the gravity flyer, I know how to find it. So I'm going to find it for everybody and show it.
No, that's going to be great because people need to be able to visually see what they're looking for in some of these, systems.
Yeah, because they don't understand it. They still think it's a battery charging a battery. They have no idea of what it's doing. You know what I mean? They don't understand the spike. They don't understand, what it's doing in that SG circuit, that it's spiking, the spikes are going in, and that they're not AC or DC on the potential, and how it's working and charging the battery. So I think that whole thing has to be gone over and showed thoroughly so that people get it. You know what I mean?
Yeah.
Because I get a lot of comments on it's a battery charging a battery, but they apparently never work with batteries because all they do is equalize when you put them together. So
right. Well, I definitely am going to be first in line for that class because I have a lot of questions regarding the Bedini circuits and some different ways of hooking up a system like that,
Yeah. Well, I think it's going to be something that blossoms into a great show. And once we get it rolling, we'll have different people on kind of like we have here. And they'll be able to show their circuit and we'll be able to ask them questions. You know what I mean? Mm-hmm. We'll just have a pre-taped version of them building it so that we can pause it and talk to them so they don't get distracted and, not be able to finish the circuit. So
no, that's a good idea. Yeah, give them time to work. Yeah, no, I was thinking about that on my workshop too. Is as I'm doing it, give the audience who is following along and building that at the same time some time to catch up and whatever.
Well, if you pre-tape it, then you could pause it and go back and you do the finer points instead of when you see the back of your lab coat. You should put a big sign back there. You know what I mean, with your name on it.
I'm gonna put a kick me sign on there. But that is actually what I'm gonna do is I'm gonna have some pre-recorded bits. Maybe just throw in some bits from we'll watch some of the video from First Stop Energies. But that is a good idea for the workshop to pre-record some stuff.
Well, no, but that's what I'm saying. Don't bring in other videos. Just bring in your video of you working on it, and then you break it down what you're doing. People, they like that a lot better than getting the distractions everywhere where they can't focus on your workshop. You know what I mean?
Yeah, I do have ADD, so it is good. Well, good idea to focus.
we watched that coil winding, right? And they missed certain big points that you wanted to point out. That's like the perfect opportunity to stop, point it out, show it. You know what I mean? I think,
and it is a good idea, Nathan. I think I definitely will do that for the workshop. I'll pre-record some bits and that'll be a good route to take that.
It'll take some pressure off you too from doing it live.
For sure. Yeah. No, because getting
dead air and sweating bullets over there.
Well, that not only that, but when you live stream, it's like you're sitting down in a chair for long periods. You need break. Like I take a break every once in a while. I have to. So, like if I'm streaming by myself, I'll have like an intermission period where I'll just play like a couple of my short videos or something while I take a break.
All right, Ben, it's getting close to 3 hours, dude. I'm done for the night.
Yeah,
I'm
me
out.
too.
You too?
I appreciate everything, Nathan. We had Ian on. That was amazing. I love his new coil that he was wrapping. I'm sure he'll get it working eventually. You know, it's you know, these things require tinkering sometimes. Like I have got to tinker with this one a little bit, but you know, I appreciate everything and I appreciate the audience, and this was fun.
Guys, thank you very much for joining us. Have a great night.
Yeah, have a good night.